Hello, good evening everyone. I hope all of you have material. है आपके पास? Okay, very good. So we'll discuss the topics given in the material. I will follow just a small departure from the order of the topics, how it is given in the material. Just a small departure. Biotechnology and health we will discuss together. First two topics we'll discuss, that will be space and information and communication technology, and then other topics I'm going to follow the same order. There are some common topics in biotechnology health, so I thought it should be discussed together. So let's start with the topics of space technology. We are going to focus upon, because this is for prelims examination, PT365, we are going to focus a lot upon the requirements for prelims examination. यहाँ पे सब ज़्यादा emphasis हमारा होगा that what should we focus upon from a particular topic, and it is based on my experience that I'm going to highlight on certain things, that things which I consider to be more important than other, but nonetheless at the same time I must tell you that UPSC can always outmaneuver us, right? So but nonetheless to focus on topics which according to me are more important for UPSC civil services examination. So for example, the very first topic which is given in your material, I'm not very sure if I consider this to be a very important topic, because UPSC ने already a question पूछ रखा है 2016 में, if I'm not mistaken, on Mars orbiter mission when it was actually launched. Right now it was in news because we have lost the contact with this mission. जो Mars orbiter mission है, we have lost the contact, and because of that it has again been in news. There are few things which we have to know in this mission. First thing first, it was only an orbiter mission. As the name suggests, the name is Mars orbiter mission. Orbiter mission simply means that it did not exactly land on the surface of the Mars. It did not exactly land on the surface of the Mars. It was orbiting around Mars. Few achievements which ISRO was able to attain with this mission, that it became the only agency till now, and first agency in fact, which was able to have a successful Mars mission in its very first attempt. This had many payloads. कोई भी जो भी ऐसे interplanetary missions होते हैं, कोई भी जो interplanetary missions होते हैं, they will have in one box you will have lot of payloads. All of those payloads are basically taking measuring different type of parameters. I don't think you have to know the name of all of the payloads. In fact, in many cases it is very easy, because out of 5, 3 has the word Mars on it. But there is a very important, of course, payload called Lyman alpha photometer, which was basically to find the presence of hydrogen, find the presence of water spatially. So at max, सबसे difficult question which I can expect in this topic is that they will give you the name of this payload and they will ask that which space mission it belongs to, and the answer will be Mars orbiter mission. Apart from that, you have thermal infrared imaging spectrometer, but here is the thing, ये जो thermal infrared imaging spectrometer है, ये आपको करीब करीब हर payload में मिल जाएगा. कोई भी आप lunar mission ले लो, Martian mission ले लो, or not just of India, of many other mission, because taking images into infrared light is always a very good thing to do. Infrared gives you a lot of information about a particular region compared to visible light. So this is not unique as such to this mission. बाकी सब में Mars नाम है, Mars exospheric neutral composition analyzer, methane sensor और Mars color camera. Simple taking picture of Martian surface into visible light, hence Mars color camera. So the only payload, if I have to remember here, will be Lyman alpha photometer. It will study the ratio of deuterium. It did study the ratio of deuterium and hydrogen, and mainly to find out the presence of water on this planet. Apart from that, I don't think anything else is required in this topic, except perhaps that as of now we have lost the contact with this mission. Maybe it is because जो solar panels हैं, they no longer are functional, because कोई भी जो probe होगा that requires an energy source. In this case, and in generally जो space probes हैं, they often rely upon solar panels. In some cases they can use nuclear technology, but most of the probes they will rely upon solar panels. So Martian probe जो Mars orbiter mission of ISRO था, that also relied upon solar panel, but as of now those panels, maybe again this can be one of the explanation, that maybe those panels are not functioning well, and because of that we have lost contact with this mission. A very important mission with respect to Mars, which if I have to remember will be this NASA's mission Perseverance rover. So compared to orbiter, while orbiter orbits around planet, जैसे चंद्रयान 1 जो इसरो का था, that was an orbiter mission, but जो lander and rover है, so lander mission can also have lander, it can also have a rover. So when I am using the word lander, it means that जो भी space probe है, that has actually landed on the surface, and rover जो है, that is going to roam around the surface, that it is going to roam around the surface, collect data, take beautiful pictures of a particular region, for example. And Perseverance rover, why this is so important? Because of the type of payloads it has been able to take beautiful pictures of Martian surface. ये जो Perseverance rover है, Perseverance rovers was able to take beautiful picture of Martian surface, and by the way, the same rover was also containing a very small helicopter called Ingenuity helicopter, and this actually became quite interesting because about 100 years earlier, Wright brothers made their first flight. More than 120, perhaps 120, 130 years ago, Wright brothers made their first flight on planet Earth, but now human beings are capable to launch a helicopter on a distant planet. So rover, which is Perseverance rover, it is active, very much active. It is collecting beautiful pictures of Martian surface, analyzing the atmospheric composition, the wind pattern, all of that. And जो Ingenuity helicopter है, that actually made a flight, and from this flight this helicopter also had a very powerful camera, and it was able to take a very good landscape picture, including the Perseverance rover, which by the way it was part of. So just two things: NASA's mission, Ingenuity helicopter, Perseverance rover, both of them are part of Martian mission. Lot of details are given in your material, but I frankly don't think they are very important. For example, you have all of these places. There is a location called Three Forks, or there is a Zero crater, or South Sita. I frankly do not think that such type of question, अगर UPSC का मन खराब हो जाए कि चलो कुछ तो पूछते हैं ऐसा कि जो पढ़ाई नहीं हो, but I don't think that this much detail, that within a foreign mission, by the way, एक तो सबसे पहले इंडिया का मिशन नहीं है. अगर सेम चीज मान लो मार्स ऑर्बिटर मिशन ने पता करा होता, that there is a crater which for the first time was which was basically known by the Mars orbiter mission, then perhaps I would have remembered it. But a rover launched by NASA and a particular location on Mars, I don't think this much level of factual information is required for science and technology classes. If you want to, you can definitely just remember in one line that all of these places are places on Mars. That's it, nothing else. इसके अलावा और कुछ भी जानने की जरूरत नहीं है. There is another, it also, by the way, it also captured solar eclipse on Mars, and Mars has, by the way, 2 moons. Earth only has 1 moon, but Mars has 2 moons, and including one of the moon, that when this moon comes between Sun and Mars, there is an eclipse on Mars also, and this rover was able to capture it. There was a payload here which was made by MIT, and that payload used certain chemicals, and there have been many more missions on Mars before Perseverance rover, and because of other missions we actually know the atmospheric composition of Mars, that what atmosphere is all about, and this payload basically was carrying certain chemicals, and with the help of those chemicals it was able to produce oxygen on the surface of Mars. So this payload, very famously called Mars Oxygen In Situ Resource Utilization Experiment, or simply MOXIE, that with some chemicals it was carrying, also some chemicals, some gases which already are present in the Martian atmosphere, it was able to produce oxygen in the atmosphere. So just in one line, I think that is more than enough. Any question in this topic? हाँ, लास्ट ईयर यूपीएससी ने क्वेश्चन पूछा था, बिल्कुल हो सकता है, सोलर फ्लेयर के कारण भी हो सकता है, बट अभी हमारे पास डेटा है नहीं. So solar flares, the question he is asking is that is it possible that this damage occurred because of solar flares? By the way, solar flares can reach up to Mars. In fact, solar flares can reach up to the entire solar system. They have so much of energy, and yes, they can even cause interplanetary missions जो हमारे उनको भी damage कर सकते हैं. But I frankly, we do not have data to comment upon it. So I will simply just say that. So Starlink is satellites because we have data here. We are collecting data about solar flare in the Earth's atmosphere, but we frankly do not have any data that how solar flares are causing damage into Martian surface. वो level of जो sophistication है, जो technological sophistication जो चाहिए वो है नहीं हमारे पास अभी. So that is why without data it will be difficult to comment. But if your question is that can solar flares cause damage to interplanetary or lunar missions, then the answer is yes. Yes, there is of course a possibility that solar flares can cause damage to interplanetary missions. Any other question? As a topic of PSLV, you should remember, not because of this mission. PSLV in itself is a very important topic. And PSLV, even though, in fact, that is, I think that is the next topic. So ISRO has many rockets. All these rockets का purpose क्या होगा? That जो top of rocket है, that carries a satellite or a spacecraft, and that is delivered into space, right? So all this entire setup, thousands of kgs, and out of those thousands of kgs, only perhaps 0.1, 0.5% of that is the actual payload which we have to deliver into space. And all of that payload is being carried with this setup called launch vehicle or rocket. We can call it rocket also. As this rocket flies, it burns because it carries lot of fuel, it carries lot of oxidizer. With the help of that fuel and oxidizer in the presence of an engine, it generates lot of thrust, right? And that thrust basically gives it it generates lot of exhaust in the downward direction, and very similar to how we can row a boat. You can push the water backward and your boat will be pushed forward. Newton's third law of motion, every action equal and opposite reaction. So similar to that, there can be exhaust from the back which can propel the rocket in the upward direction. And ISRO has many types of rockets as of now. All of them are given into a list here, and I actually do think that information about all of them, and definitely one of them, two of them in fact, that is SSLV and LVM3, you should definitely know because both of them were in news into last 1 year. But even PSLV is very important. So let me briefly summarize in fact all of the rockets of ISRO. So as of now, ISRO has 4 active rockets, 4 rockets which it is using for different type of mission. PSLV is one of the oldest rocket of world. Definitely it is the oldest functional rocket of ISRO. There were rockets before PSLV such as simply SLV. There was a rocket called SLV, Satellite Launch Vehicle, or ASLV, Augmented Satellite Launch Vehicle. But as of now, they have been decommissioned. In fact, why we should know about PSLV, there is one more reason, because PSLV is also going to be soon decommissioned. When exactly it will happen, that is not very clear, but ISRO chairman has made it very clear that perhaps in next few years, when PSLV का जो भी contract है, जो भी requirements है, when we fulfill the requirements, it is going to be decommissioned. Timeline is however not clear. So PSLV has been a very reliable launch vehicle. Decade 55 launches it has made, failed only perhaps twice or thrice. It has a success rate of more than 96%. Very few rockets can claim this, that they have a success rate of more than 96%. Originally it was designed to deliver Earth observation satellites. So I'm talking about different types of satellites here. I can have different types of satellites. जो Earth observation satellites हैं, as the name suggests, they monitor Earth from an orbit. They monitor Earth. They calculate different type of data about different surfaces on the Earth. So originally it was intended to deliver Earth observation satellite into polar orbits, and hence the name is Polar Satellite Launch Vehicle. तो इसका जो capability है, it can launch a payload. Payload simply means how much it is carrying. Payload is what is being carried here, right? This entire rocket is of course thousands of kg of mass, but there is a very small mass here which is being carried by this rocket, and that small mass has to be delivered into space. So PSLV, and of course it depends upon कि कितना मास है, कितना ऑर्बिट आप पहुंच पाओगे. इमेजिन कर लो, इसको इस तरीके से सिंपली इमेजिन कर सकते हैं, हाउ मच पेट्रोल यू हैव इन योर कार, एंड डिपेंडिंग अपॉन दैट हाउ मच डिस्टेंस यू कैन ट्रैवल. So PSLV can carry a payload of about 1750 kg into 600 kilometer orbit, and but however that does not mean that it cannot be used for geosynchronous orbits. So there is an orbit called geosynchronous transfer orbit, and in this transfer orbit it can carry a payload of about 1400 kg. So your question was that do we need to remember that MOM was launched by PSLV? So not for MOM, but for PSLV you should know. PSLV has launched many satellites, remote sensing satellites into low Earth orbit. वो आपको याद नहीं रखना. But there are some remarkable launches done by PSLV, some of the milestone launches done by ISRO. For example, 3 examples are outstanding here. First is Chandrayaan 1, not 2. Chandrayaan 2 के लिए we used GSLV MK3 और LVM3, which is called LVM3. But जो Chandrayaan 1 है, sorry, Chandrayaan 1 was launched using PSLV. Mars orbiter mission was launched using PSLV, and जो हमारे नाविक सैटेलाइट्स हैं, which are basically called IRNSS satellites, they were, by the way, these satellites are into geosynchronous orbit. I will come to the orbit also. These satellites are into geosynchronous orbit, and they were launched using PSLV, because नाविक satellites का जो mass है वो बहुत ज़्यादा नहीं है. So if mass is not very high, then you can also use PSLV for launches. So I think these are the 3 outstanding launches of PSLV. If you can remember, you should. But generally designed to launch what we call Earth observation satellite or a remote sensing satellite. Both are exactly same thing. Earth observation or remote sensing satellite. So generally, the word here is, the emphasis is on generally, that generally it launches Earth observation or remote sensing satellite, but from time to time there can be some special launches, and these will be 3 examples. Just especially Navik satellites, which by the way are placed into geosynchronous orbit and geostationary orbit. So even for so if there is a statement that PSLV can only be used for lower Earth orbit, that is of course going to be a wrong statement. Then we have another very famous rocket called GSLV MK2. इसका जो first variant था GSLV MK1, that ISRO did not use, that was decommissioned very soon. But इसका जो second variant है GSLV MK2, as the name suggests, the full form is Geosynchronous Satellite Launch Vehicle. So can you ask someone to bring a globe also? हाँ globe चाहिए. So Geosynchronous Satellite Launch Vehicle. अब ये जो Geosynchronous Satellite Launch Vehicle है, as the name suggests, it is for geosynchronous orbit at the height of 35,786 kilometer, and at such height what you often use is communication satellite. तो जो GSLV MK2 है, that was mainly designed for communication satellites to be placed into geosynchronous transfer orbit. Now compared to PSLV, which by the way has 4 stages, that it has an engine which carries solid fuel, then it has an engine which carries liquid fuel, again solid fuel, liquid fuel. So it has 4 stages, and all these stages will burn one by one. They will get separated, and finally that satellite or whatever it is carrying, that will be ejected into space. So while PSLV has 4 stages which alternates between solid fuel and liquid fuel, जो GSLV MK2 and MK3 है, that is 3 stage. That first stage carries solid fuel, then second stage carries liquid fuel, and the third stage carries what we call cryogenic fuel. So GSLV is made of 3 stages. One of these stage, or highest stage, that is called cryogenic fuel. By the way, in both these liquid stages, ये जो liquid stage engine है of GSLV and PSLV, that is called विकास engine. ये भी याद रहना चाहिए. Liquid fuels are very difficult to store and transport. Often they are quite expensive because of that. So liquid fuels pose their own unique set of challenges, that how we are going to use them in the rocket. Using solid fuel is easier. Transporting them, storing them, that is easier. But solid fuel के साथ एक बहुत बड़ा problem ये होता है कि once you start the burning, you cannot control the burning. Only when the fuel will be exhausted, then your engine is going to be separated, rocket stage will fall down. So that is a huge demerit of solid fuel, that even though they are cheaper, it does not require a lot of money to store and transport them. So overall their cost is less, but there is a huge challenge that you actually cannot control the flow of fuel to the engine. Liquid तो है नहीं कि आप flow control करोगे. तो since you cannot control the flow of the fuel, once the fuel starts burning, then you cannot actually control the required thrust. Engine, all the fuel will be exhausted and engine will then shut off, that rocket stage will be separated. So in any case, sorry, scramjet हम discuss करेंगे defense में. हमको discuss कर रहे हैं scramjet क्या होता है, हम defense में discuss करेंगे. Scramjet does not carry oxygen. It fulfills its oxygen requirement from atmosphere. But I will come to scramjet engine जब हम defense technology discuss करेंगे. जो GSLV MK, so by the way, both of the liquid stages of PSLV and GSLV, they use an engine that is called Vikas engine. Also, the third stage, cryogenic, this is also quite important. First of all, the meaning of cryogenic word should be very clear. Cryogenic basically means very, very low temperature. Very low, I am talking about -160, -170, -200. मैं ऐसे रेंज ऑफ टेम्परेचर की बात कर रहा हूँ. सो क्रायोजेनिक सिग्निफाइज वेरी लो टेम्परेचर. एट वेरी लो टेम्परेचर, लॉट ऑफ एटमॉस्फेरिक गैसेस सच एज लेट्स से हाइड्रोजन एंड ऑक्सीजन, दे एग्जिस्ट इनटू लिक्विड स्टेट. जो ऑक्सीजन है वो लिक्विड स्टेज में होगा, जो हाइड्रोजन है वो लिक्विड स्टेज में होगा. नाउ हियर इज द थिंग, हाइड्रोजन इज अ वेरी गुड सोर्स ऑफ एनर्जी. आई थिंक देयर इज अ टॉपिक ऑन हाइड्रोजन एज अ सोर्स ऑफ एनर्जी, परहैप्स या तो इस साइंस टेक में ना तो इन्वायरमेंट में, आई डू नॉट रिमेंबर. But if it is in science tech, then we will discuss it in science tech. Hydrogen as a source of energy. Now hydrogen is a very good source of energy, but the problem is how to store it. That is a separate problem. But one very simple way of storing hydrogen as a source of energy is in liquid form. However, hydrogen can only exist in liquid form at very low temperature and at very high pressure. So in cryogenic stages, we often maintain that condition, that you have very low temperature, so that your fuel, which is hydrogen, and your oxidizer, which is oxygen, both of them are into liquid stage. You also require material which can sustain such low temperature. There are very few material which will not degrade or which will maintain their integrity despite, जैसे higher temperature problematic है, lower temperature भी problematic है. So there are few materials which can maintain basically such low temperature, and they will not degrade. So the cryogenic stage है, that is often a very complex, a very difficult stage to achieve. But why do we do this then? And the reason is very simple, because for the same amount of fuel, जो cryogenic है, that is going to give lot of thrust, lot of impulse compared to a typical solid fuel or a typical liquid fuel. जैसे जो typical solid fuel हम PSLV में use करते हैं, that is a fuel called HTPB, hydroxy terminated polybutadiene. I think it is given in your material also. And जो liquid fuel हम use करते हैं, that is often a type of fuel called hydrazine fuels. So we use a type of fuel called UDMH, unsymmetric dimethyl hydrazine, only for prelims examination. And the max सबसे obvious question जो मैं expect करूँगा, that they will just give you the names and they will ask that what are they. what are these chemicals, उसमें बहुत सारे option होंगे. It is an insecticide, it is a persistent organic pollutant. One of the option will be it is a rocket propellant, and that will be the correct answer. तो ये जो molecules है HTPB or UDMH, these are rocket propellants. This is a solid fuel, this is a liquid fuel. Now compared to this solid or this liquid fuel, ये जो cryogenic fuel है, which basically is liquid hydrogen plus liquid oxygen, they give you lot of impulse. Same amount of fuel, but ये जो आपको impulse देंगे, that will be much more, and that is why cryogenic fuels and cryogenic stages are so important in general for rockets. As of now, India has developed its own indigenous cryogenic engine. अभी तक क्या था कि 2012-13 तक we were very much dependent upon import, especially we had import from Russia, but now in 2014 ISRO announced that we have developed our own indigenous cryogenic stage, and in all MK, GSLV MK2 or LVM3 we are using our own cryogenic stage. So apart from the capacity of GSLV MK2, which is, if you have any question, please ask question from me. So 6000 kg into LEO and about 2250 kg into GTO, and 3 stages solid, liquid, cryogenic. You should also know that the final stage is called cryogenic stage. This one? Which part? For LEO, lower Earth orbit. If you have to attain an orbit, so lower Earth orbit, I will come to the orbit classification. इसके बाद मेरा next topic वही है, because वो भी आपके material में दे भी रखा है. So we'll talk about types of orbits and their utility. Geosynchronous transfer orbit. I will discuss orbit classification in just next topic. ठीक है? I will discuss that. The most powerful rocket which ISRO has, by the way, इसके इन दोनों के बारे में specially पता होना चाहिए. This made a record recently, and its second launch, first launch was unsuccessful, but second launch, which happened by the way in February itself, I think on 7th of February, that was a successful launch. So ये दोनों पता होने चाहिए. These two are the newest rockets of ISRO. That is the strongest, this is the lightest rocket, but nonetheless both of them are very useful. So ISRO made this rocket called GSLV MK3, which was an upgradation of GSLV MK2. Very similar to GSLV MK2 in the sense that this also has 3 stages, solid, liquid and cryogenic stage. But compared to GSLV MK2, इसका जो capacity है, that is 4000 kg into geosynchronous transfer orbit and 8000 kg into lower Earth orbit. Now why we have renamed it? So the same GSLV MK3 now has been renamed as LVM3. तो ये भी पता होना चाहिए कि LVM3 and GSLV MK3 same है. We have renamed it, but why we have renamed it? And there is a good reason for it. Because ISRO generates lot of revenue from its rocket. ये clear होना चाहिए सबको. ISRO has 2 commercial wings. ISRO has 2 commercial wings under it. New Space India Limited and Antrix Limited. With the help of these commercial wings, ISRO generates revenue also. So, sorry? InSpace is a regulatory body. I will come to that part. Discuss करना है हमको. InSpace के बारे में भी हम discuss करेंगे. InSpace is a regulatory body. It's not a commercial wing. So ISRO, for example, from time to time, it will launch satellites of other countries or satellites made by private companies. तो वो ऐसे कोई free में नहीं है. मतलब ISRO generates lot of revenue from launching those satellites. Right? So GSLV का जो G था, that signified geosynchronous, so often it signified that it is perhaps for communication satellite. But right now, this rocket actually made a record. It launched 36 satellites weighing approximately 6000 kg into an orbit of, if I'm not mistaken, about 1200 kilometer, which is still lower Earth orbit, of a company called OneWeb. Now it seems like a lot of factual information, but let me deconstruct them one by one. OneWeb is a private initiative वन वेब का पर्पस ये है कि हम सैटेलाइट्स को यूज करके इंटरनेट प्रोवाइड करेंगे पूरे दुनिया में. वी आर गोइंग टू प्रोवाइड इंटरनेट, बट अभी जो हम इंटरनेट डे टू डे लाइफ में यूज करते हैं दैट एक्चुअली रिलाइज अपॉन ऑप्टिकल फाइबर केबल्स. वन वेब का फोकस ये है दैट वी आर गोइंग टू यूज सैटेलाइट्स फॉर दैट. देयर इज अनदर वेरी फेमस प्रोग्राम very similar to OneWeb called Starlink. That is a program of SpaceX. Elon Musk का जो initiative है Starlink, that we are going to launch thousands of satellites into LEO and we are going to provide global internet. OneWeb had similar plan. The difference is that this is LEO of about 400-450 kilometer. OneWeb is at higher altitude, about 1200 kilometer. Sorry? ब्लू ओरिजिन अमेजन की कंपनी है. OneWeb खुद में एक स्पेस सैटेलाइट बेस्ड इंटरनेट इनिशिएटिव है. ये वैसे तो कंपनी यूके बेस्ड है, बट देयर इज अ वेरी इंटरेस्टिंग फैक्ट एज ऑफ नाउ. OneWeb का भी जो लार्जेस्ट स्टेक होल्डर है वो एयरटेल है. तो एयरटेल विच इज एन इंडियन कंपनी, एंड वन ऑफ द रीजन व्हाई इसरो मे हैव गॉट दिस कॉन्ट्रैक्ट बिकॉज एयरटेल हैज एक्चुअली एज ऑफ नाउ एयरटेल इज द लार्जेस्ट स्टेक होल्डर in OneWeb initiative. So it is an initiative of many organizations together. One of those organization is Airtel, which is by the way an Indian company. The goal of OneWeb is to provide satellite based internet all across the world by launching satellites into low Earth orbit. And recently 36 of their satellites were launched by LVM3 or GSLV-MK3 simultaneously, which weighed around 6,000 kg, and that was a record for ISRO. For ISRO it is a record. Other space agencies have launched heavier weights into different orbits. But ISRO made a record of launching about 6,000 kg into LEO, and that is why you have to know. Now one of the reason why we have renamed it, because LVM3 का जो full form है that is Launch Vehicle Mark 3 rather than G. So G signified geosynchronous, but Launch Vehicle Mark 3 simply signifies that a rocket which can be used for any type of orbit. Just in this case it is a low Earth orbit, right? Hanji, you have a question. No, ऐसा कुछ भी regulation नहीं है. There is no. So the question is that is there a regulation that private companies can only launch satellites into low Earth orbit? If your question is that why they are launching into low Earth orbit, and there is a very good answer to that, to reduce latency. But we will talk about that in next topic, ICT topic, right? So as of now, LVM3 is the most powerful rocket with a capability of 8,000 kg into 600 kilometer orbit, 4,000 kg into geosynchronous transfer orbit, very similar to GSLV MK2. It also has 3 stages, solid, liquid and cryogenic. Chandrayaan 2 for example, that was launched using GSLV MK3 or LVM3. तो Chandrayaan 3 है वो एक बहुत remarkable launch होगा GSLV MK3 का. There is a very good chance that जो गगनयान मिशन है इसरो का, that may also be launched with the help of LVM3, right? And then the latest rocket which has been developed by ISRO, that is simply small satellite launch vehicle. So small satellite launch vehicle, पहले तो objective clear होना चाहिए कि why this small satellite launch vehicle. Now here is the thing, जो PSLV है generally for lower orbit launches, if you have to go up to height of 400-500 kilometer, you are relying upon PSLV. But PSLV का जो capability है for such heights, it is about 1750-1800 kg. So you need to have a payload of 1750-1800 kg. Only then it makes financial sense that you are launching, you are planning a PSLV. So often ISRO apart from its own, मान लो कि ISRO का खुद का अपना एक payload होगा, let's say weighing 600 kg. But then only for 600 kg payload, designing entire PSLV, by the way, which is quite costly, does not make lot of sense. So what ISRO will do, ISRO will often wait for perhaps more orders, maybe some private companies, maybe some other countries, they have their own plan, and together we can plan a PSLV. But then you have to wait. So SSLV जो है, the purpose of SSLV is that its capacity is very less. First thing, capacity इसका बहुत कम है. The capacity is only 500 kg into 500 kilometer orbit, right? But nonetheless, it is a smaller rocket. It can be, because the capacity is very less, even for a very small launch, we can plan it very fast, we can assemble it very fast, and we can launch it also quite easily. So a cost effective launcher with capacity of 500 kg into 500 kilometer orbit, 3 stages. This is the first stage. only using solid fuel, second stage again solid, third stage again solid, and there is a very small module here, but ISRO in its official website has not called it a stage of rocket. They have used a word, a module, a velocity trimming module. If you go to ISRO's website, then they haven't called it a 4-stage rocket. They have called it a 3-stage rocket. In the initial 3 stages, it is going to use solid fuel. But जो final जो एक module है, it will have a motor, it will have some liquid fuel, and with the help of that liquid fuel, because remember liquid fuel का जो flow है, वो हम control कर सकते हैं. So with the help of this liquid fuel, जो final थोड़ा बहुत जो adjustment करना पड़ेगा in the satellite's orbit, we can do that. Hence the word trimming, that we are talking about controlling the velocity of our rocket, velocity of our satellite. So a 3 stages, the goal again here is to reduce cost. That is why all the 3 stages, they are using only and only solid fuel. None of these stages are using liquid fuel. So a cost effective launcher can be planned in a shorter duration of time. Capacity is very less, but nonetheless, rather than using PSLV for smaller launches, we can simply use SSLV. Another reason why you should know, it made its first flight, I think last year in the month of September or October, but the very first launch of SSLV that failed. Sorry? In the month of August. Okay, so in the month of August, SSLV made its maiden flight. It is relatively a new rocket. ये 2020 में इसरो ने announce किया था that we have made a new rocket. It was planned 2022 में पहली बार हमने use करा in the month of August. Even though it was able to deliver the satellite, but it was able to final जो orbit था वो बहुत ही different था from what was desirable. We had desired a lower Earth orbit, a circular orbit, but the final orbit was a highly elliptical orbit. इतना डिटेल में जानने की जरूरत नहीं है. What you have to know, that very first launch of SSLV that had failed. So ISRO made some changes, learned from its mistake, and just last month on 7th of February, its second flight, it was carrying 3 satellites. One of those satellites was a remote sensing satellite of ISRO, and it was successful. So in its second attempt, it was successful. So because both these rockets were in news for different reason, and that is why you have to know about them. नहीं, बिल्कुल भी नहीं. ये कि एक यूएस का था, कोई कौन सी प्राइवेट कंपनी का था, बिल्कुल भी याद नहीं रखना. नो, आई डोंट थिंक कोई भी इतना लेवल पे एक्सपेक्ट कर रहा है कि दिस वाज कैरिंग 3 सैटेलाइट्स, एंड वन ऑफ द सैटेलाइट वाज अ रिमोट सेंसिंग सैटेलाइट ऑफ इसरो. देयर वर 2 अदर सैटेलाइट, बट वो 2 किसके हैं इतना ज़्यादा डिटेल में जानने की हमको ज़रूरत नहीं है. सो दिस इज अबाउट रॉकेट्स ऑफ इसरो. 4 रॉकेट्स, PSLV will be commissioned perhaps in next 2-3 years. ISRO is right now planning on another rocket, which as of now it is calling it NGLV, next generation launch vehicle. The goal of NGLV, that we are trying to achieve 10,000 kg capability into GTO, and twice of that, that is 20,000 kg capability into LEO. So this is what ISRO's plan is right now, that जो हमारा next rocket होगा जो PSLV को replace करेगा, that is going to have a capability of perhaps 10,000 kg. But we do not know a lot about this next generation launch vehicle because ISRO hasn't made all of the information public. Publicly they have just said that we are right now working on a new rocket. That new rocket may have capability of 10,000 kg into geosynchronous and 20,000 kg into lower Earth orbits. One more thing they announced is that this rocket may also have a reusable variant. Reusable का मतलब ये होता है, I'm using a word here. Reusable का simply मतलब ये है that at least जो आपका first stage है, that first stage you are able to recover it properly and you are able to reuse it. जो भी हमारे अभी के जो भी rockets हैं, none of them are reusable. All of them, कोई भी PSLV के बाद आप देखोगे एक suffix भी आएगा that you will have some PSLV C55 or something like that. So all PSLV is a different rocket. So we do not actually, and that is why space launches are so expensive. So lot of space agencies, they have worked on this concept of reusable rocket, especially again this company called SpaceX. So SpaceX जो Elon Musk की company है, they have made a rocket called Falcon, and Falcon has done wonders into this reusable capability, right? So ISRO is also planning to do something like that. That NGLV जो होगा उसका at least एक variant ऐसा होगा जो हो सकता है reusable हो. But nonetheless, I don't expect a question on NGLV simply because this was part of a presentation by ISRO chairman, and apart from that, there is no public information available about this development, right? नहीं Falcon नहीं है. सबसे heaviest I think as of now जो heaviest launch है that will be जो Artemis जो NASA ने बनाया था. But SpaceX is actually working on a very heavy rocket which can perhaps carry 40,000 or 50,000 kg. But वो अभी बना नहीं है, वो उसमें टाइम लगेगा, हो सकता है कुछ लगे कुछ टाइम. But SpaceX is actually working on a rocket which can carry a payload of about 40,000 or 50,000 kg. हाँ वही Falcon Heavy का ही एक वेरिएंट है. बट अभी जो heaviest launch जो है that has been done by NASA's Artemis mission, which I am going to discuss in the next topic. No, cryogenic is jo liquid solid, it's not liquid solid cryogenic. Where PT365 had mentioned liquid solid cryogenic. In LVM3, I don't think so. I think it is a mistake. So in LVM3, the first stage is mentioning liquid here. I think it is a mistake. This should be corrected. So first is solid, second is liquid, third is cryogenic. Very similar to GSLV Mk2. Any question in the rockets of ISRO? Okay, that's a very good question. The question is that on what basis we decide the solid or liquid propellant. So depends. So for example, first stages often will have solid fuel, and however if reusable it can also use liquid fuel, or at least oxidizer can be liquid. The goal here is that if you only need thrust, you do not need to control things. The rocket often uses a combination of fuel, combination of engines, because we want to get best of the benefit of both solid and liquid fuel. Another very good reason of such combination will be that higher stages, once one stage is separated, controlling them into higher and higher stages with smaller rocket, it will be better. You can control it in a better manner. So wherever you require control, for example, that you need more control over your rocket, then often we will use liquid fuel. Whenever the requirement is only thrust, that focus is more on thrust, less on control, we will focus on solid fuel. But if, let's say for example, wherever you can use solid fuel, we will try to use solid fuel simply because it is cheaper. तो टेक्नोलॉजी का एक बहुत इंपॉर्टेंट एस्पेक्ट ये भी होता है that how we can do the same thing in less cost, right? So whenever you can use solid fuel, we will try to use solid fuel. So economy also plays a very important role. What is the accidents? So first of all, that is not entirely true, because failure can, the question is asking that what is the reason that why immediately rockets fail. So rockets can fail in any of these stages, in first, second or third stages. But why immediately? For example, if the first stage fails, why immediately? Because everything is normal, suddenly you have such huge amount of heat generation, temperature rises into thousands of degrees Celsius. If not all parameters are exactly working on what you calculated, if any of the parameters are not working properly, such huge amount of heat energy that can lead to explosion. So that is why often rocket के जब भी accidents होंगे, जो भी explosions होंगे, they will often happen in the very first minutes of the launch itself. But by the way, this accident can also happen in the second or in the third stage, and again in the same case, second stage start होगा, accident हो सकता है, third stage start होगा, accident हो सकता है, right? Any other question? One more thing which is given in your material is different types of orbits. Now to understand, to appreciate different type of orbits, we first need to, I think, appreciate different types of satellites. That what type of satellites we often use. Whenever we use the word space technology, then we can have a type of satellite which is called communication satellite. Or I can have a type of satellite which is called Earth observation satellite. or I can have a satellite called navigational satellites. Now, all of them are doing different objectives, different things. जो communication satellites हैं, they are very useful, that you can maintain communication contact between 2 points which are on Earth very far away from each other. 2 points on Earth, they are very far away. Because of Earth's curvature, so many obstructions, they cannot maintain a direct communication line. एक तो Earth का curvature है, spherical body है, ऐसा तो है नहीं कि flat है. तो spherical body है, because of that, Earth curvature itself is going to block long range communication. But Earth curvature के अलावा there are so many restrictions, there are mountains, buildings, so many things. So often we send satellite, we use a satellite to maintain a connectivity. However, for such satellites, it actually makes lot of sense that ये satellite है, it should be able to receive communication from this particular point most of the time. For example, let's say if this point is here, but satellite is here behind the Earth, it will not be able to receive this communication signal because Earth is blocking its line of sight, right? So ये बड़ा important. Can everybody appreciate this? That because I'm talking about communication, in communication there is a ground station, and this ground station is sending a signal, right, towards Earth station. Anupama देखना है आपको TV पे, right? So in that case there is a ground station that is sending a signal, and with the help of a nearby satellite in the sky, that satellite is broadcasting signal back to the planet Earth. But if the satellite is here, then you do not have line of sight. So often you will try to ensure that जितना ज़्यादा आप ऊपर जाओगे Earth के, जितना ज़्यादा आप ऊपर जाओगे, more and more area of Earth is in your line of sight. So for example, if you are closer to Earth, then perhaps you can maintain a communication with a very small part. But if you are farther away, then you can maintain a communication over a much larger part simultaneously. So आप जितना ऊपर जाओगे, maintaining communication in a larger area will be easier compared to maintaining communication into a smaller area. That is one very important parameter. But there is another very important parameter which is rotation of Earth, but I will come to that part later. Now compare that with Earth observation satellite. Earth observation satellites जो हैं, they are basically collecting data about Earth. If you have to simple एक सबसे obvious example I can take, imagine them taking picture of Earth. But it is not simple picture, these are very sophisticated picture. They are collecting data about a particular region. If you are collecting data from far away, going very far away can be problematic. Because if you are very far away, then the quality of data you are collecting, that will be compromised. If you are nearer to a particular location, then जितना ज़्यादा near आप होगे उतना better आपका resolution होगा. Imagine resolution as a concept जो हम day to day life में use करते हैं कि अगर आपको बहुत दूर का कोई picture लेना है, आपको बहुत zoom out करना पड़ेगा. जितना zoom out करोगे जो picture का quality है, that is going to worsen. So you have to be perhaps in vicinity so that you can collect better quality data. So that is why जो Earth observation satellites हैं, they ideally should be kept into lower Earth orbit, not very far away from Earth. जो navigational satellites हैं, they use some sort of compromise, that not very navigational satellite का by the way purpose क्या है, that they tell you the location, that where exactly you are on the Earth, what is your latitude, what is your longitude, what is your altitude, even what time zone you are in, they can tell you that also. So they provide you locational and timing services, that what is your latitude, longitude and altitude along with the time. That is the purpose of navigational satellite. Often these satellites are kept into medium Earth orbit, about 20,000 kilometer. तो पहले तो types of satellites देख लो, that these are types of satellite. Now based on these types of satellites, I can have different types of orbit. So for example, I can have an orbit called low Earth orbit, which varies from 180 to 2000 kilometer. I can have a medium Earth orbit, which varies from about 2000 to 785 kilometer. Or I can have geosynchronous orbit and high Earth orbits, which can be greater than or equal to 35,786 kilometer. तो जो लोअर अर्थ ऑर्बिट्स हैं दे आर गोइंग टू बी मोर यूजफुल फॉर remote sensing satellites or earth observation satellites, because from such height calculating data about earth's surface, the data quality is going to be better. You can do remote sensing from here also at 40,000 50,000 kilometer, but the type of data you are going to calculate or going to collect, that type of data is going to be frankly seriously compromised. So it does not make a lot of sense to use remote sensing from very high orbits. Yeah, geo is geosynchronous. It is full form of geosynchronous orbit. जो geosynchronous orbits हैं, there is a word here, geosynchronous. I will explain that also. But geosynchronous orbit जो है, that is useful for communication satellite. And जो medium Earth orbits हैं, they are very useful for navigational satellite. Not always, by the way. जैसे जो इंडिया का जो navigational program है, that actually uses geosynchronous orbit. But जो सबसे famous world का navigational program है, that is of course GPS. All of us use GPS in our mobile phone, and जो GPS satellites हैं, they are actually into medium Earth orbit of about 20,000 kilometer. So I can have this classification based on height. So I can have this classification based on height, that low Earth orbit from about 180, 2000, 2035, 780, more than 35, 785, 786, high Earth and geosynchronous orbit. But I can also have orbit based on inclination, that compared to equator, मान लो ये जो पूरा point है, this entire plane here is equator. ये equator है. Now compared to equator, इसका एंगल क्या है? फॉर एग्जाम्पल दिस ऑर्बिट सैटेलाइट इज, इसको हम यहाँ पे ग्लोब पे इमेजिन कर सकते हैं, दैट इफ आई हैव अ सैटेलाइट विच इज जस्ट मूविंग अबव इक्वेटर, देन आई कैन कॉल इट सैटेलाइट इनटू इक्वेटोरियल ऑर्बिट. आई कैन कॉल दिस ऑर्बिट टू बी इक्वेटोरियल ऑर्बिट. बट आई कैन ऑल्सो हैव अ सैटेलाइट विच इज मूविंग फ्रॉम पोल टू पोल, नॉर्थ पोल टू साउथ पोल, सो आई कैन कॉल इट पोलर ऑर्बिट. और मोस्ट ऑफ द ऑर्बिट्स विल बी एक्चुअली इंक्लाइंड, that they will make some, and by the way जो inclination है we measure it from equator. तो equator का inclination is 0 degree, and depending upon that क्या inclination is, it can be 0 to 90, it can be more than 90 also. For example, if I have a satellite like this, if I have a satellite like this, then ये जो angle है, this angle is more than 90 degree. So I can have an inclination from 0 to 180 degree. Now polar orbits are often quite useful for Earth observation. This is what I wanted to emphasize upon. जो polar orbits हैं वो काफ़ी useful हैं Earth observation के लिए, and there is a very good reason for it, because Earth is in a way rotating below these satellites. So these satellites are revolving above Earth, but Earth is rotating. तो हर point of Earth कभी ना कभी satellite के line of sight में कभी ना कभी आएगा ही आएगा. अगर मान लो same चीज़ हम equator पे कराना है, if it is above, मान लो कि it is at 500 kilometer, it can observe a very small area around equator because it is not very far away. बहुत ज़्यादा होता तो फिर ये ज़्यादा एरिया देख पाता, but because it is let's say at 500 kilometer height, it can absorb a very small area and it is above equator, then it is only going to observe only those small area, right? ये इक्वेटर के अलावा और आसपास ये जैसे पोलर एरिया वो कभी देख ही नहीं पाएगा. It can never monitor the polar area. But if I have Earth rotating and satellite revolving above it, जैसे for example at this point of time satellite was revolving like this, but by next revolution Earth has rotated a little bit. Now it is observing another point. Now it is observing another point, another point, another point. So in each and every successive revolution, it is going to find different and different points on Earth, and that is the benefit of polar orbits. And that is why PSLV का जो full form है, that is Polar Satellite Launch Vehicle, because after all it was designed for remote sensing or Earth observation satellites. And Earth observation satellite का जो सबसे suitable orbit होगा, that will be a polar orbit of about let's say 600, 700, 800 kilometer. So it has to be an LEO, lower Earth orbit, as well as a polar orbit, right? So that is the best point, best location to find Earth observation. And even within polar orbit, there is a special case, and that special case is called sun synchronous orbit. Now sun synchronous orbit, I will only make just one statement. Apart from that, I am not going to discuss about it. I don't think detailed discussion about sun synchronous orbit is required, but sun synchronous orbit का एक बहुत important characteristic ये है that they maintain a continuous line of sight with respect to sun. Imagine that sun is here at this point, and as Earth revolves around sun, these satellites will maintain a constant orientation with respect to sun. So the amount of sunlight they receive, these satellites, as they revolve around Earth, that is not going to differ a lot. So whenever they are crossing above a point, they will cross in the same amount of sunlight. इसको आप ऐसे imagine कर लो that if there is a satellite crossing above Delhi at 12 afternoon, 12 afternoon का मतलब मेरा है that sun is exactly above the satellite. So next time when it is going to cross Delhi, again sun will be above the satellite. Whenever it is going to cross Delhi, sun will be above the satellite. So such type of orbits, and why this is so important, because if you are collecting data in the same amount of light, that data makes more sense. आप ऐसे imagine कर लो, take your selfie in bad light, take your selfie in good light. Good light में बढ़िया selfie आ जाएगी, बढ़िया picture आ जाएगा. So you can imagine it like this, that change of lighting. After all, we are talking about collecting data, we are talking about optical equipments, and optical equipments collect data in the presence of light. And same amount of light is always a very useful characteristic. So, and ये जो sun synchronous orbit है, they are polar orbit. इनका जो inclination होगा, that will be about 96 to 98 degree, and इनका जो height होगा, that will be 600 to 800 किलोमीटर. सो यही होगा जो वेदर सैटेलाइट्स हैं. द क्वेश्चन इज, जैसे जब हम बात करते हैं अर्थ ऑब्जर्वेशन का, अर्थ ऑब्जर्वेशन कैन डू लॉट ऑफ थिंग्स. आई कैन फाइंड, डू नॉट थिंक ऑफ देम टेकिंग सिंपल पिक्चर. जो अर्थ ऑब्जर्वेशन सैटेलाइट्स हैं, दे कैन फाइंड द प्रेजेंस ऑफ अ पर्टिकुलर केमिकल, कि एक एरिया में कार्बन डाइऑक्साइड कितना है, मीथेन कितना है, उस एरिया का टेम्परेचर ओवरऑल कैसे वैरी करता है, और मॉइस्चर कैसे वैरी करता है फ्रॉम सीजन टू सीजन. So it can determine the physical, chemical, even biological properties. जैसे UPSC ने क्वेश्चन पूछा था that a remote sensing satellite can find the amount of chlorophyll from a particular location, and yes, that is actually correct. तो जो remote sensing satellites हैं, they can collect data about presence or absence of any type of chemical. So they can collect data about physical parameters such as amount of moisture or amount of, let's say, what is temperature, wind velocity, things like that. These are physical parameters. But then there are chemical parameters also. For example, presence or absence of a particular chemical or a particular element. Because of this, the remote sensing satellites, and they are also used for resource exploration. जैसे मान लो that there is a region where you have underground water resources, or you have oil and natural gas. तो ऑयल एंड नेचुरल गैस जहाँ पे भी होगा, वहाँ का जो सरफेस होगा, दिस विल बी लिटिल डिफरेंट कंपेयर टू द सराउंडिंग सरफेस. तो एक जो हमारा एक्सप्लोरेशन होगा, दैट विल बी जियोलॉजिकल सर्वे, दैट गो एंड डू जियोलॉजिकल सर्वे. बट अगेन वी कैन ऑल्सो यूज, और वी कैन फर्दर कलेक्ट डेटा फ्रॉम रिमोट सेंसिंग सैटेलाइट, दैट डू वी हैव रिसोर्सेज हियर और नॉट. सो लॉट ऑफ मैप्स, आप सबके पास एटलस होगा. In this atlas you find physical map, political map, but you also have map about resources, that a particular resources kahan pe milte hai. Lot of that map has been actually prepared by ISRO, that with the help of remote sensing satellite, ISRO has collected information about presence or absence of particular type of resources into a particular region. So remote sensing satellites in our day-to-day life, we do not use them, but for governments, for private companies, they are going to be very useful. So remote sensing satellites का ideal location is LEO, even within LEO, polar, even within polar, sun synchronous, right? अभी मैंने बताया, no, तो इक्वेटोरियल पे आप सिर्फ इक्वेटर एरिया कर पाओगे ना. देखो अर्थ का जो रोटेशन है, अर्थ इज रोटेटिंग लाइक दिस. इफ आई एम revolving above equator, imagine earth is not rotating, earth had stopped, I am revolving above equator. I am not very high altitude, my height is 500 kilometer. Maybe I can monitor a small area around equator. So I am revolving around equator, I can monitor this area around equator. But even if earth is rotating, how does it benefit me? Doesn't benefit me in any way. Earth is rotating, I am revolving, I am still collecting the same type of data. Imagine earth not rotating but a polar orbit. I can perhaps control a small strip here, right? But now earth is revolving rotating below me. So as I revolve above Earth, Earth is rotating below me, and because of Earth's rotation I can actually monitor each and every point of the Earth at some point of my flight. So polar orbits are going to be very useful for remote sensing satellite, and even within polar orbit, जो sun synchronous orbit है, they are quite useful because they maintain constant orientation with respect to sun, not with respect to Earth, but they do maintain constant orientation with respect to sun. मैं उस नेक्स्ट मेरा यही था टॉपिक. तो ये तो हो गया कि इंक्लिनेशन पे. अब एक और एक बड़ा इंपॉर्टेंट यूजफुल ऑर्बिट है विच इज कॉल्ड जियोसिंक्रोनस और जियोस्टेशनरी. तो कम्युनिकेशन में आई टोल्ड यू वन थिंग दैट इफ आई एम वेरी फार अवे, राइट, इफ आई एम वेरी फार अवे, देन आई विल बी एबल टू मेंटेन अ कम्युनिकेशन डेटा विथ दिस इंटायर रीजन. अगर मैं बहुत दूर हूँ तो एनी ग्राउंड स्टेशन हियर आई कैन मेंटेन दिस डेटा, बट आई कैन ऑल्सो यूज one more characteristic and that is Earth's rotation. अब देखो अर्थ जो है रोटेट कर रहा है. If I synchronize the satellite's revolution with Earth's rotation, that let's say for example imagine a point just below India on the equator, there is a satellite here at some height, and as Earth rotates and completes one rotation, the satellite also completes one revolution. So Earth rotates on its axis in about 24 hours, satellite also completes its one revolution in 24 hours. So क्या होगा कि जैसे जैसे पॉइंट रोटेट हो रहा है, सैटेलाइट हमेशा उस पॉइंट के ऊपर है. As Earth rotates on its axis, this satellite is always and always above this equator. That is what we call geostationary. So geostationary simply means, geo means Earth, stationary that with respect to a point on Earth, this satellite seems to be fixed in the position in the sky. Because Earth is rotating, satellite is revolving, there is a synchronization. अब sorry, यहाँ पे भी हो सकता है. वेदर सैटेलाइट हम पोलर ऑर्बिट में भी रख सकते हैं और हम जियो सिंक्रोनस में भी रख सकते हैं. हाँ, सन सिंक्रोनस में भी रख सकते हैं. सो वेदर सैटेलाइट्स का जो है, मोस्टली वेदर सैटेलाइट्स जो होंगे दे विल बी केप्ट इनटू एलईओस डिपेंडिंग अपॉन कौन सी कंट्री है. अगर मान लो पोलर ऑर्बिट है तो और भी बेटर है. इट कैन कलेक्ट डेटा अबाउट मेनी रीजन्स इंक्लूडिंग पोलर एरियाज. एक तो सबसे पहले पोलर ऑर्बिट का एक और बहुत बड़ा बेनिफिट क्या है, दैट आप कहीं पे भी चले जाओ पोल तो आपको नहीं दिखेगा. अर्थ हैज अ कर्वेचर, बिकॉज ऑफ दिस कर्वेचर दिस पोल ब्लॉक इज blocked basically. If you are however flying above pole, then you can collect data about poles also. So there is another benefit of polar orbit. So हाँ, तो जो remote sensing satellites जो specially weather satellites हैं, they can be placed either into polar orbits or in general LEO or also into geostationary or geosynchronous orbit. तो जो geostationary है, it seems like that it is the satellite is fixed with respect to a point on Earth's equator. So if I have a ground station anywhere, it can maintain a continuous communication channel. So that is a very useful characteristic for communication satellite. But ये खाली equator के ऊपर होगा. इसके अलावा कोई भी inclination है, but at the same time it maintains the same characteristic that it is completing one revolution in 24 hours. I can call it geosynchronous. So geosynchronous का definition is very simple. Any satellite whose revolution is synchronized with Earth's rotation is geosynchronous. But geostationary is a special case that it is synchronized but also above equator. So दो चीजें अगर साथ में हो जाए, that yes it is synchronized, it is making one complete revolution in 24 hours, but it is also above equator. Because above equator का क्या फायदा होगा, that it will always seem to be fixed in a point in the sky. जो geosynchronous है, देखो ये fixed नहीं होगा. It will not seem to be fixed, especially if it is not 0 degree. Let's say I have an inclination of 20 degree here. That ये जो geosynchronous orbit which I have drawn in this picture, let's imagine, although it is more than 20 degree, but let's imagine that this inclination is 20 degree. Now as Earth rotates, this satellite is going to revolve. तो ये fixed तो नहीं दिखेगा, but it will look perhaps somewhere going up in the sky. It will be somewhere in the sky for half of the period, and when it comes here, it will go down in the sky. So it will seem to be oscillating somewhere in the sky, but still it is quite useful because if there is a ground station, it can maintain a continuous communication channel with a satellite into geosynchronous. तो आपका जो क्वेश्चन था कि geosynchronous geostationary सेम है अलग है, तो अलग इस सेंस में है कि जियो सिंक्रोनस बड़ा वर्ड है और जियो स्टेशनरी जो है उसका एक स्पेशल केस है, दैट जियो सिंक्रोनस एनी ऑर्बिट विच कैन मेंटेन a satellite revolution period of about 24 hours is geosynchronous, but if it is above equator then it is also geostationary, right? So geostationary in that sense is only one orbit, एक ही orbit है. By the way we already know कि time period is 24 घंटे में इसको revolve कर जाना है. अगर आप time period पहले से लेके चलो, इसका जो height आता है that comes out to be 35,786 किलोमीटर. तो जो geosynchronous orbits हैं उनका जो हाइट है दैट इज 35,786 किलोमीटर. सॉरी, बिल्कुल भी नहीं 20 डिग्री, मैंने सिर्फ एक एग्जांपल लिया था. इट कैन बी 90 डिग्री, 95 डिग्री, 130 डिग्री, डजंट मैटर, एक्सेप्ट ओनली थिंग विच हैज टू मैटर इज टाइम पीरियड. वो हमेशा 24 घंटे होना चाहिए. एज लॉन्ग एज इट इज 24 आवर इट इज जियो सिंक्रोनस. इफ इट इज 24 आवर एज वेल एज 0 डिग्री इंक्लिनेशन then it is geostationary. ठीक है. So geostationary is a special case of geosynchronous. किस सेंस में? अगर हम अर्थ ऑब्जर्वेशन करना हो हमको, तो ऑब्जर्वेशन हमारा पर्पस ही नहीं है ना. बाय द वे दैट इज, यू आर टोटली राइट, यू टोटली. तो कम्युनिकेशन में भी मेन हमारा पॉइंट क्या है, that let's say for example this is my satellite. If I have any ground station here on this part of the earth, it can maintain a communication channel. Yes, you are right. So your point is that यहाँ पे नहीं होगा तो हम एक और यहाँ पे launch कर देंगे. So I can have 2 satellites and I can maintain 24/7 वो. Same goes with GSO also. Yes, बिल्कुल, without any doubt. पूरा अर्थ तो कभी नहीं कवर कर पाएगा. And in fact in some countries they have actually launched their remote sensing satellite, not communication. They have actually launched their remote sensing satellites into geostationary orbit so that they can actually cover a larger part of Earth simultaneously. Somebody had a question here. Hanji. Sorry, higher? Higher payload can be, what is your question? Is your question that polar are more difficult or easy? ये question है आपका. तो same height पे अगर हम बात करेंगे तो polar launches are more difficult. If I'm talking about same height, so it has to, दो फैक्टर है, एक तो हाइट भी है. अब जियो सिंक्रोनस ट्रांसफर ऑर्बिट है, दैट इज अल्टीमेट हाइट इज 35,786. पोलर मैक्सिमम जो हम हाइट यूज करेंगे 800, 900, 1000 किलोमीटर, उससे ज़्यादा यूज नहीं करेंगे. तो सेंडिंग इनटू 1000 किलोमीटर इज ऑलवेज गोइंग टू बी इजियर कंपेयर टू सेंडिंग इनटू लेट्स से 36,000 किलोमीटर. बट nonetheless, so I will change the question, that same height, that let's say a height of 800 kilometer into equator, into pole, where it is going to be more difficult, the answer is pole. And the reason is very simple, because whenever a satellite is being launched from equator or an equatorial orbit, it already has lot of assist from Earth's rotation, right? But jo polar orbits hai, in case of polar orbit you do not actually get lot of help from Earth's rotation. So if my height is same, if I have to attain the same height, then polar launches are more difficult compared to equatorial launches. And in one line the answer is because जो equatorial launches हैं they will get a boost from Earth's rotation. जो polar launches हैं they will not get any boost from Earth's rotation. ये जियोसिंक्रोनस में एक पॉइंट किसी भी पॉइंट से फिक्स नहीं दिखेगा. थोड़ा सा इमेजिन आपको करना पड़ेगा कि मान लो इंक्लिनेशन कुछ ऐसा ऑर्बिट है, and as Earth is rotating, this satellite is revolving. तो जैसे मान लो कि if I have a satellite which is revolving like this, not like this, but revolving like this. So as Earth rotates, जैसे मान लो कि satellite यहाँ पे था, as Earth rotates, it will go up in the sky, right? Go up in the sky, further up, half of the time up, but now it is going down in the sky, down in the sky. So it will still maintain a line of sight from a particular ground station. However, it will not seem to be fixed except 0 degree. At 0 degree it will seem to be fixed. At other angles it will not seem to be fixed. It will look somewhere oscillating in the sky. But still I will be able to maintain a communication channel, and by placing satellites at strategic location, I can cover the entire Earth and I can maintain 24/7 communication, right? So that is the beauty of geosynchronous and geostationary orbit. So this is about types of orbit. हाँ, आई विल कम टू दैट पार्ट, आई विल डिस्कस, वो भी करेंगे, आगे डिस्कस करना है। आपका क्या क्वेश्चन है? why do you think that? So how distance and noise क्यों हो जाएगा? Noise, signal distortion can occur because of distance, not distortion but signal spread can occur. But even 36,000, and now we have lot of technologies. The question he is asking that is that from higher altitude the signal is going to be distorted. By the way, जो भी noise होगा, noise के लिए एक presence of source होना चाहिए. There should be some source of noise. Since we are talking about space, no matter you go at 5,000 or 50,000, space जो है mostly empty है. There are few things here and there, but they are not causing as such lot of problem. So noise source in space, they are very limited. There can be some sources in the space also, but very limited. Once you are on Earth, then there are a lot of noise sources. So in that case, जो altitude है, that actually plays a very less role in especially noise. One thing which can occur is what we call spread of signal, but that effect can be minimized. We have actually developed a lot of tools that how we can minimize spread of signal. Any other question? Its orbit, but generally we would, why would we do that? The question is that can, by the way, the answer is yes. Satellites do carry some amount of fuel. They do carry a motor also, and they can be given a boost. So for example, the question about geosynchronous transfer orbit, that मान लो that ये हमारा final orbit है, that ये हमारा final जो geosynchronous orbit है वो ये है. Often what happens is that whenever you are launching a satellite with the help of a rocket, we do not often attain the same orbit in one go. We attain an orbit which will look like something like this. It will be a highly elliptical orbit where the closer part of ellipse, by the way, which is called perigee will be few hundred kilometer, and the apogee hai, that will be about 36,000 kilometer. Once it reaches the apogee, satellite is carrying some fuel. It has a motor. With the help of that fuel, we can give it a boost, or we can give it a boost at perigee also, by the way. And ये जो orbit होगा, this was my desirable geosynchronous orbit. I am going to, जो हमारा rocket है, that is going to leave us into this orbit. अगर हम इसको छोड़ दें satellite को, so the orbit will look something like this. But satellite does have some fuel, it has a motor. With the help of that fuel, we can give it a boost so that it is placed into a higher orbit. Again, we can give it one more boost and we can place into our desirable orbit. तो ये जो बीच के orbits हैं, this first one or second one, I can have third one also, or I can just have one orbit. तो ये जो बीच के orbits हैं, these temporary orbits are called geosynchronous transfer orbit. So as the name suggests, transfer orbits. So जैसे next time जब आप news पढ़ोगे, with a launch of GSLV into geosynchronous, then you are going to find that this rocket has delivered the satellite into geosynchronous transfer orbit, GTO, not geostationary or geosynchronous. After that, we will use some fuel which is left in the satellite, part of the satellite itself, and we can give it a boost and we can keep attaining the higher and higher orbit, and we can keep doing that until we find our desirable orbit. जो हमारा desirable orbit है, that will be a geosynchronous or geostationary orbit, and बीच के जो भी orbits हैं, they are called geosynchronous transfer orbit. Depend करता है, launch vehicle तो चलो तो कहीं launch vehicle हम कहीं पे deliver करेंगे, perigee और apogee जो भी होगा. If your question is that जो boost हम कहाँ पे देंगे, so I cannot call that certain point as the perigee. My launch vehicle का purpose है, the question is asking that where will launch vehicle basically eject the satellite. The launch vehicle has to eject the satellite with certain speed so that after it can maintain a stable orbit because of Earth's gravity. The orbit is maintained because of Earth's gravity. अब वो जो orbit है उसका perigee apogee, that will actually be decided upon how much impulse initially was given. Because of that impulse, it is going to start revolving around Earth. It is going to find a balance because of its own motion and because of Earth's gravitational force, and that balance will be its orbit, right? As long as there is no opposing force, it will maintain that orbit. But if I have to change the orbit, that was the question, that can we change the orbit? So yes, we can. In some cases, जैसे geosynchronous transfer orbit में, that will be desirable, but once you have achieved the final orbit, then it does not make a lot of sense to change the orbit, right? Satellite completes one revolution in 24 hours. That is what I said. One revolution around Earth. Of course, every revolution it is going to, one revolution 24 hours, again second revolution 24 hours. Yes, that is correct. Somebody else had a question. In this one, transfer orbit. So yes, we did. However, only one thing, that ये जो transfer orbit है, that is earth-bound orbit. जो मंगलयान है, that is actually we have to cross Earth with the help of moon. You have to give it a motion towards Mars. So such type of transfer orbits are used into any type of lunar launches or any type of Martian launches, but it is much more complex than this simple geosynchronous transfer orbit. Yes, तो हमारा पूरा पर्पस यही है कि हम अर्थ के ग्रेविटी को थोड़ा बहुत फ्यूल हम फिर भी रखते हैं कि फ्रॉम टाइम टू टाइम इफ वी हैव टू मेक सम एडजस्टमेंट वी कैन डू दैट, बट हमारा गोल यही है दैट सैटेलाइट शुड बी एबल टू मेंटेन इट्स मोशन बिकॉज ऑफ अर्थ्स ग्रेविटेशनल फोर्स. देखो, I cannot take a question of space technology in detail, like I have lot of topics, I have limited time period, so please be more ठीक है, ask few more questions, but after that I will go to the next topic. So at a particular longitude, yes, that is correct. At a particular longitude, yes, that will be true. No, sun synchronous is presence of sunlight. So the question is that a satellite, let's say for example a satellite into geosynchronous, let's say I started above India, and after 24 hours, जैसे मान लो कि अभी क्या time हो रहा है, it is 6:30, it is going to be 6:30, that satellite is at above India at 6:30, completed one revolution, again came back above India, again next day 6:30, that is correct, right? In geosynchronous or geostationary. Now compare that with sun synchronous. Now sun synchronous, first of all, it has nothing to do with my standard time. It has nothing to do with what my watch is telling me. It has something to do with what is the position of sun in the sky. That maybe if it was crossing above India, or be more specific, maybe it is crossing above Delhi at a particular inclination, at a particular height, at when sun was exactly above the satellite. Whenever it is going to cross over Delhi, I do not know when will that be, whenever. Maybe it is next day, maybe it is within next few hours, maybe after 3 days. But the goal here is that whenever it is going to cross over Delhi, the position of sun should be similar in the sky. That is how they are different. There is a question that weather disturbance or heavy cloud cover, do they have any effect on signal transmission? Yes, they do have. So the weather disturbances, especially rainfall, snowfall, they do have disturbances on the signal transmission. At for every point on equator, yes. So for example, इसके geostationary है, ये घूम रहा है जैसे ऐसे. So satellite whenever it is, so because it is at fixed point with respect to Earth, तो एक तरीके से आप ये बोल सकते हो कि यहाँ पे जो टाइम हो रहा है, अभी जो भी टाइम था, इसी टाइम के हिसाब से पूरा सैटेलाइट भी घूम रहा है. So for example, if it was at 6:30, at 7:30 this is here, this point is here, satellite is also here, 8:30, 9:30, right? So again, same time 6:30 at the same point, at the same original position. Because my geosynchronous is, the question is that why geostationary is called a type of geosynchronous? Because fundamentally I am trying to synchronize my satellite's revolution with Earth's rotation. That synchronization can be achieved at any inclination, including 0 degree. 0 degree has this additional benefit that not only it is synchronized, it seemed to be fixed with respect to a point on equator. So synchronization can be achieved at any inclination, hence geosynchronous. But at 0 degree there is one additional benefit. So we are using a special word for it, simply called geostationary. बिल्कुल करेगी, कैसे नहीं करेगी सन सिंक्रोनस. अब ये जो क्वेश्चन है कि सन सिंक्रोनस में हम कैसे इंक्लिनेशन मेंटेन करते हैं सन से, I don't think that discussion is required here for prelims examination. It will take a lot of time. I have to discuss a lot of topics. Ab class ke baad discuss kar lena. If you are interested, that the question he's asking is that how can satellite maintain fixed orientation with respect to sun if Earth's gravitational force is present here? So I don't think, frankly, it is required. It has something to do with what we call orbital precession, but I don't think we have time to discuss orbital precession right now. The next topic which is given in your material is, yes, NAVIC. आगे आएंगे, आदित्य मिशन है, वेब टेलीस्कोप है, वहाँ पे L1 L2 हम डिस्कस करेंगे डिटेल में. So नाविक जो है इंडिया का नेविगेशनल सैटेलाइट प्रोग्राम है. तो कुछ नेविगेशनल सैटेलाइट्स हैं. नेविगेशनल सैटेलाइट्स, the purpose, as I told you, that their objective is to tell location and timing of a particular point on Earth. Location का मतलब है latitude, longitude and altitude. Now how do they do that? For that, for example, they often use an electronic receiver. जैसे मान लो हमारे जो मोबाइल फोन्स हैं, all of our mobile phones have a small electronic receiver. With the help of one small electronic receiver, this mobile phone is receiving data from a nearby GPS satellite. Let's assume as of now GPS as a reference point. GPS, by the way, is a navigational satellite program of US. US government का program है. So let's assume that this mobile phone is receiving data from one satellite. Now that signal, by the way, that जो GPS है, that has a very powerful clock also. That clock is called atomic clock. Atomic clock can measure time with very, very high precision. So how much time it has taken for that signal to travel from this satellite to the receiver, to this electronic receiver, based on that it can calculate how far away it is. But here is the thing, if I know that something is far away from me, मान लो मैं बोलता हूँ कि there is a point on this board, there is a point on this board which is, let's say, 10 meter away from this point. That मैं आपको बोल दूँ कि इस point से 10 meter दूर I have a treasure. But then you'll have to find this treasure on a circle, because I have only given you distance. I haven't actually given you other coordinate. I have only given you distance, and I'm saying that from this point, 10 meter away from this point, there is a treasure. But then that treasure can be anywhere on this circle. I need one more information to know the precise location of this treasure. That is on the board, and board is a plane. Now imagine the same thing into 3 dimension. That if I say that where I'm standing, there is 10 meter away from me, there is a treasure. Now I have to basically make a sphere, and that sphere, the treasure can be anywhere on that sphere. So if this electronic receiver is receiving signal from one of the satellite, that satellite will tell you that how far it is from this electronic receiver. But then I can be anywhere on this sphere around this satellite. So just receiving signal from one satellite is not enough. I have to receive signal from more satellites. It can be shown with the help of geometry, but we do not have to do that here, that to know the precise location of a particular region, I need this signal from minimum of 4 satellite. If I receive minimum of 4 satellite, then I can actually know my precise location, that where exactly on Earth I am. What is my latitude, what is my longitude, what is my altitude. Now why this information is important? Because ISRO has this program called NAVIC, and NAVIC comprises of just 7 satellites. These 7 satellites, 4 of them are kept into geosynchronous and 3 of them are kept into geostationary, and they provide navigational information in the India and subcontinent region of India. So if you go to ISRO's website, it tells you that you can find navigational information in the India and 1500 kilometer beyond India's border. That 1500 kilometer beyond India's border, you can actually find the navigational information. Now good thing here is that as Earth rotates, these satellites are revolving above Earth, and because they are into geosynchronous and geostationary, they will always be above Indian region itself. Isn't it clear? That because these satellites are kept into either geosynchronous, and even in geosynchronous they are not frankly at very high inclination, or a 10 degree above, 10 degree, 4, 1 here, 1 here, 1 here, 1 here, and 3 very near to India. And as Earth rotates, these satellites are also revolving. So these 7 satellites will always and always be focused towards Indian subcontinent region. So because of that, I can find navigational information into India and 1500 kilometer beyond India's border. Compared to that, जो GPS है, that is a global program. GPS is, so if I have to compare Navik and GPS, I will come to Gagan also. Wait for the topic to be completed. I will come to Gagan also. What exactly is Gagan? If I have to compare Navik and GPS, सबसे पहले तो Navik जो है इंडिया का प्रोग्राम है, GPS यूएस का प्रोग्राम है. Similar to GPS, I have other programs also. For example, GLONASS is a program of Russia, or Galileo is a program of Europe. Ideally, you should know these names. GLONASS is a satellite navigation program of Russia. Galileo is a satellite navigation program of Europe. Then there is a program called BeiDou, that is of China. All of them are global. GPS, GLONASS, Galileo, BeiDou, they can provide you navigational information anywhere on this planet. जो नाविक है, that is regional, that it can provide you in India as well as 1500 kilometer beyond India's border. So in the entire subcontinent region, जो GPS है, that is global. जो नाविक है, that comprises of 7 satellites. जो GPS है, that is generally more than 30 satellite. 32, 33 active रहते हैं, 32, 33 हमेशा active रहेंगे, but it will definitely be more than 30. So 32 to 33 satellites always remain active in GPS program. And because of that, anywhere on this planet you go, you at least will be in line of sight of 4 GPS satellites. In fact, the number will be more than 4. It will be 5, 6, 7, 9, 10 also. Anywhere on this planet go, you have information, you are in the line of sight of more than 4 satellite, and you can find your navigational information, your latitude, longitude, altitude anywhere on this planet. So that is the difference. Another more difference here is that these satellites are kept into geosynchronous and geostationary orbit, and they are kept into medium Earth orbit. So about 20,000 kilometer. Now why this topic was in news? तो इतना तो information पहले clear होना चाहिए that while Navik is a regional navigational program, it can provide you latitude, longitude, altitude into India and Indian subcontinent region. First, second, it comprises of 7 satellites which are placed into 4 of them are into geosynchronous, 3 of them are into geostationary. Compared to that, GPS is a global program, or GLONASS, Galileo, BeiDou, they are global program, and they are placed, at least the GPS that is placed into medium Earth orbit of about 20,000 kilometer. Even China has a similar strategy as India. The Chinese BeiDou satellites, they are also placed into geosynchronous and geostationary orbit. But nonetheless, this is the difference. Now why this topic is in news? There are 2 reasons why it should be covered into news. One reason is that as of now, Government of India has requested all mobile phone companies that you should also be Navik compliant. That हमारा जो mobile phone है, whenever you are sending location on WhatsApp or using Google Map, then basically you are using GPS satellites. So Indian government is asking that for all the mobile phones which are being sold into India by even foreign companies, they should have an electronic receiver, and that electronic receiver should be able to receive signal from Navik satellites. That is a request to further improve this, that even companies do not have to invest a lot. So what Navik has done here is, that is the other reason why this was in news, that for civilian uses, by the way, जो GPS satellites हैं और in general जो navigational satellites हैं, they have both civilian and military uses. जो civilian use जो हम WhatsApp पे location भेजते हैं, Google Map use करते हैं. जो military uses होगा, that will be, for example, if I have to guide a missile, that a particular location you have to hit, or a drone. So any type of guided attack, and जो military applications हैं, they are always restricted. They are only and only available to people who have proper authentication. So often these people will be military personnel, intelligence officials, so on and so forth. जो normal लोग होगा, उन normal लोगों के लिए ये required नहीं होगा. Because हमारे neighbors बहुत अच्छे हैं, so we have developed this program. By the way, one thing is that during Kargil war, basically India had requested restricted services from US, but US had denied it. So a need was felt that we have to develop at least as of now for the subcontinent region. Maybe we will expand it to a global level. So maybe NAVIC will become a global program, but as of now it is a regional program. So because Indian government has actually requested mobile phone companies to become NAVIC compliant, so as of now this is going to add a type of spectrum called L1 spectrum band. So whenever you are sending or receiving signal, you are basically sending or receiving radio signals. Radio signals are a type of electromagnetic wave very similar to visible light. जिस तरीके से visible light एक electromagnetic wave है, radio wave भी electromagnetic wave है. The difference is wavelength. जो visible light का wavelength है, that is very less, frequency is very high. जो radio wave का wavelength है, that is larger, frequency is very less. Now for what purpose, what type of radio wave you are going to use, that is actually decided by a body called International Telecommunication Union. There is a very important organization called International Telecommunication Union, that for what purpose, what type of satellite will be used. Sorry, for communication satellite. For communication also means lot of things. Even GPS you are receiving or transmitting signal from a nearby GPS satellite. So even though it is for navigational purposes, but in a way you are actually receiving or transmitting signal. So for what communication purpose you are receiving what type of frequency band, that is decided by a body called International Telecommunication Union, which is a UN agency, United Nations का part है. So United Nations, this ITU, it has decided radio frequency into many bands, and especially जो satellites हैं, they use a band from about 1 to 40 gigahertz. And this 1 to 40 gigahertz is further divided into many sub bands. The lowest band is called L band, and L band is from 1 to 2 gigahertz. And this L band is actually very useful for GPS satellites. The GPS satellites हैं, they use frequency of L band. By the way, this L band is again further divided into L1, L2, etc. तो जो L1 band है, which is given here, this L1 spectrum band, that is, if I am not mistaken, somewhere around 1.5 gigahertz. So 1 to 2 के बीच में आता है 1.5 gigahertz. And this 1.5 gigahertz is very useful for, till now it has been used for GPS satellites also, and now even government of India is going to integrate that, at least for civilian purposes. If you are into India, then you do not have to be dependent upon NAVIC, sorry, on GPS. You can easily rely upon NAVIC services, and for that this change has been made, that our satellites now are going to use L1 spectrum band. नहीं, उसका रिलेशन नहीं है. बिल्कुल है, बहुत सारे फोन्स में ऑलरेडी कंप्लाइंट है. हाँ बिल्कुल नहीं, L1 introduction is relatively new, but हाँ overall functioning it was using other frequency band, because this has applications into civil. As I told you that for what purpose, what type of frequency band will be used, that has been decided at the global level. Now why this decision is important? Because अगर सब कोई अपने मन से कुछ भी use करने लगे, this will lead to lot of interference. Signal quality is going to deteriorate. We do not want that to happen. That for particular purpose, particular frequency band should be used. So this allocation is done at the global level. It is now up to all the countries that based on the global standards, you have to make your own standards, you have to make your own rules and regulations, so that you can apply those rules and regulations into India. Right? तो ये एक बहुत important चीज़ जो हाँ, तो अभी तक जो हमारा मेन एप्लीकेशन था वो मिलिट्री रेंजेस में हम कर रहे थे, बट नाउ वी आल्सो हैव सिविलियन एप्लीकेशंस. सो एज ऑफ नाउ गवर्नमेंट ऑफ इंडिया इज आस्किंग दैट ऑल मोबाइल फोन कंपनीज दे शुड हैव अ रिसीवर, इलेक्ट्रॉनिक रिसीवर which can receive signal from NAVIC apart from GPS, and because of that this topic was in news. Sorry, what was your last point? Mm-hmm. 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 But I'm very sure even in that street view, it will not be for the entire India. So question is asking, is that the Google Street View, which is by the way very famous feature of Google, it has till now been denied into India, and there is a very good reason for it, security reasons. It is for internal security reasons. So Google got permission, but again not for the entire India. For certain heritage sites, as of now, जो street view है, that is available for certain streets, heritage sites, etc. It is not available for pan India level. That at pan India level आप street view नहीं दिखा सकते. But yes, मैंने street view कभी ज़्यादा use करा नहीं है, तो I cannot actually comment upon the feature, that what type of features street view has. Can communication satellites be launched into polar orbit as it can cover larger area? Please. So first of all, it cannot cover larger area. If I am talking about polar orbit, then polar orbit का जो सबसे ज़्यादा suitability है, that is about 600-700 kilometer. So at 600-700 kilometer, if you do not have a much, at one point, remember communication is at one point of time, you are receiving a signal from a particular location. Because if you are into LEO, you are revolving very fast. जो LEO satellites हैं, they will revolve around in 1 to 2 hours. They will make one complete revolution of Earth in just about 1 to 2 hours. If your height is, let's say, from 500 to 800 kilometer. So you do not have actually a line of sight from a particular point for more than a minute, in fact. So the lower Earth orbit satellites, they are not very useful, including polar orbits. If polar orbit, which is LEO, is not very useful for communication, simply because you will not be able to maintain a continuous line of sight from a point on Earth. But nonetheless, to overcome this challenge, what you need to do, you have to have many satellites that make a grid of satellite all across the planet, and then yes, you can have a communication network. By the way, Elon Musk is doing precisely this. That जो Starlink program है, that comprises of thousands of satellites which are placed into LEO. So if you are talking about satellite based internet, after all it is also an example of communication, right? For communication you generally use geosynchronous geostationary, but जो Starlink है, that is actually being launched into lower Earth orbit. Lower Earth orbit में challenge क्या है, that at one point of time you have line of sight from a very particular area. So if you want to cover more and more area on the Earth, you have to have many satellites, and that is what he is doing right now. That he is planning to launch, already launched by the way, thousands of satellites into sky, which can provide global internet anywhere on this planet. There is one more question, that why sun synchronous orbit is placed at such low height as compared to geosynchronous. It has something to do with the property. जो geosynchronous का property क्या है कि time period of revolution जो है, that has to be 24 hour. If you have this property, it's a simple mathematical calculation, but we do not have to do it. That अगर time period 24 hour है, तो height satellite का कितना होना चाहिए? It's not a very difficult calculation, but if you do the calculation, the height of that satellite will be 35,786 kilometer, right? जो sun synchronous orbit है, उसका criteria क्या है? That your satellite's orientation with respect to sun, that should not change. Even though with respect to Earth it may change, but with respect to sun it should maintain the same angle. Again, that is also a mathematical problem, more complicated mathematical problem compared to the earlier one, but nonetheless it is a mathematical problem. If you solve that mathematical problem, your answer will come out to be height of 600 to 800 kilometer, inclination of 96 to 98 degree. And because it is also a polar orbit, best combination हो गया हमारे पास. हाँ, Gagan, there was a question about Gagan. So what exactly Gagan is? Now Gagan is an older program. Gagan is actually an older program than Navik, but Gagan has very limited application. Gagan का जो application है, it was developed by ISRO in collaboration with Airport Authority of India. जो Airport Authority of India है, that works under Ministry of Civil Aviation, and the goal here is to provide, or was to provide, navigational services for our civilian aircraft movement, जो भी airplanes हैं. So by the way, this is a dedicated infrastructure which comprises of our own communication satellites, GPS satellites, then data centers on ground. These data centers are receiving lot of data from satellites, from and using communication satellite they can actually send communication to airplanes. So a proper well developed infrastructure including our communication satellite, GPS satellites, as well as ground data centers to help civilian aircraft movement in their flight. So that is with that objective Gagan was developed, but as of now it has applications into other areas also. For example, it is also being used, if I am not mistaken, by railway for some other government programs also. So initially it was for air traffic control, but now for road, railway, even for farmers, for fishermen it is being used. So its application is in many more areas, but nonetheless जो initial objective था that was focused on the aircraft movement, जो especially civilian aircraft movement है. And by the way, this Gagan program is older than Navik. And Gagan program में जो satellites हम navigational satellites use कर रहे हैं, that is actually GPS satellites, not Navik satellites. Maybe right now, अब जो है धीरे धीरे हम क्या करेंगे, we will keep using our own navigational satellite, Navik satellite. But as of now, जो Gagan program जो पूरा built up है, that was with the help of GPS satellites. Any question till now? Sorry. So, जो airlines है basically, airlines, airplanes requires lot of precision, right? Lot of precision, especially around airports. Even in fact, if they are flying into, let's say, lower stratosphere, even then they require lot of awareness about their presence, that what type of weather condition, are they part of jet stream or not. Especially during landing, it still becomes even more important because lot of flights are landing or taking off. You do not want any type of accident. By the way, such accidents have occurred, that where airplanes have collided near airport itself. So for such cases, a proper global standard has been developed, that navigational programs which can be relied upon for such for airline takeoff or landing. And as of now, Gagan has this. So Gagan has this focused localizer performance with vertical guidance, that during landing and during takeoff, it can provide you lot of precision regarding your navigational awareness, and using that you can avoid any type of accident. And this has been certified by the way a global body, and that is why this topic was in news, that Gagan along with very few other programs, such as there is a program of US called WAS, or program of Europe called IGNOS, or Japan has a program, that all of these programs have been developed to support airline movement. And Gagan now, as of now, it is along with all these programs which can be relied upon, especially if you are flying into Indian subcontinent region. So because in our Gagan program we are taking the help of GPS satellites, जो भी हमारा ये augmentation, so augmentation simply means that जो भी navigational awareness है, we are trying to enhance it. Augmentation has a very simple meaning, that we are trying to enhance, in this case, awareness about our navigation, that where exactly you are, what is your latitude, longitude, etc. And here we are taking the help of GPS satellite. That is the meaning of this Gagan program. So जो Gagan का full form है, so it simply means that GPS aided geo augmented navigation, that with the help of GPS satellite we are actually helping our civilian aircraft movement, right? Simple. So that simply means that we are taking the help of GPS satellite. Artemis mission, I think it is an important mission for prelims examination, even though it is a mission of NASA. There are few things about Artemis mission which you should know. First, it is first of the lunar mission into a larger program. NASA का जो ultimate plan है मैं बता देता हूँ. NASA का ultimate goal है that let's make a proper platform on moon surface. That platform will be supported by a space station which is going to orbit around moon, not orbit around Earth. So NASA has a larger plan. By 2040, 2045, they want a proper base at moon, and that base will be helped by a space station which they are calling Lunar Reconnaissance Orbiter, and that space station is going to orbit around moon. So this is a very ambitious plan because no other agency has as of now thought about going beyond Earth space. So NASA is planning to make a space station around Moon. Ultimate goal is that with making Moon as a base, we can have now interplanetary exploration. For example, you can go to perhaps Venus or Mars first. Of course, another very important objective is that Moon may have lot of resources, and those resources are going to be very useful. Lot of resources which, by the way, are depleting on Earth, but on Moon you have, for example, presence of those resources. That may also be a very important goal. So in 1969, NASA became the first agency, of course, with the help of what we call Apollo mission. Sabko pata hoga hai, Neil Armstrong, Buzz Aldrin, two person who became the first astronauts to set their foot on Moon surface. Now in Greek mythology, Artemis is sister of Apollo. So when in 2019 NASA announced that to commemorate 50 years of Apollo mission, 1969, 50 years, 2019, NASA announced that we are planning another lunar mission. This will comprise of 3 mission. तो जो Artemis 1 है उसका गोल बहुत सिंपल था, that in Artemis 1 mission first of all NASA used a very powerful rocket, its own developed rocket, did not rely upon any other private company. This was a rocket developed by NASA itself, its own rocket, which can basically send this very heavy spacecraft. Its name is Orion. So this Orion spacecraft was delivered into orbit much above Earth, so that finally it can make a orbit towards Earth. That was the goal. This was an unmanned mission. Nobody was part of this mission. The goal was that Orion will try to maintain a stable orbit around Moon. And by the way, that stable orbit which NASA has calculated in itself is very, very interesting. It is a type of orbit which is called retrograde orbit. Now what retrograde orbit means is that जो Moon का revolution around Earth है, do not go into this complexity of this picture. In very one line, the meaning of retrograde is very simple, that Moon is orbiting around Earth in this direction. ये जो satellite का revolution around Moon है वो opposite direction में होगा. Why NASA has done it? Because they now know that in such orbits are much more stable because they get some sort of gravitational input from Earth also. So the retrograde orbits हैं. So first I will explain what, I will again repeat. The word for this Orion spacecraft, the goal of Artemis mission is that let's send this Orion spacecraft into a lunar orbit, and especially into an orbit called distant retrograde orbit. Distant means it is very far away from Moon. Retrograde means that जो Moon का revolution around Earth है, ये जो Orion spacecraft का जो revolution around Moon था, that was opposite to Moon's revolution around Earth. And this opposite was there because it provides more stability around lunar orbit by consuming very less fuel. That even with less fuel, you can maintain more stability into such retrograde orbit. NASA wanted to test it. That let's check it. That is why it was an unmanned mission, and this was successful. So ये calculation था पहले, a mathematical calculation based on a computer simulation that this can be done. Now the first mission was to check it. Now that first mission has become successful, the second mission is going to have a manned mission. But this manned mission will be perhaps, I think by 2025 it will be launched. But this manned mission is not going to land on the surface of the Moon. It will orbit around Moon, come back on Earth. The third mission which NASA is planning perhaps by 2026 or 2027, Artemis 3, that will have a manned mission, and that is going to actually land on the surface of the Moon, and they will start their next phase. By the way, ये जो 3 खत्म होगा तो उनका next phase शुरू होगा, that they have to now start making a platform on Moon, and they have to start making a station around Moon itself. That is their long-term plan. So you have to know about Artemis mission, that 3 missions. The first was unmanned mission. The goal was that send this spacecraft called Orion. Overall the name of this mission is Artemis, but send this spacecraft called Orion, achieve distant retrograde orbit, come back to Earth in a very stable manner. Now that is also very important because this was also covered by all newspapers. So I actually do think it is important for examination, even though it is not given in your material. A concept called skip entry, that while coming back, जो Orion spacecraft था, that maintained what we call skip entry. Now skip entry का मतलब क्या होता है? If you have ever used a flat stone on a lake, आप फ्लैट स्टोन को अगर आप एक बिल्कुल वेलोसिटी दोगे तो इट विल गो इनसाइड द वाटर, अगेन कम बैक, अगेन गो डाउन, अगेन कम बैक. इट कैन डू दैट डिपेंडिंग अपॉन हाउ स्किल्ड यू आर. करा आपने? राइट, आई एम वेरी श्योर सम ऑफ यू मस्ट हैव डन इट. आई एम टॉकिंग अबाउट समथिंग लाइक दिस. कर नहीं पाए? But you can actually do it. So the goal here is that inside water, you throw a stone, it goes inside the water, comes back, again goes inside the water, comes back. So skipping. So basically it gets a boost from the water itself. Now while Orion was coming back, one of the objectives NASA wanted to attain is that very similar to this, it wanted to attain what we call skip entry. That first it entered in the atmosphere, with the help of atmospheric boost again it went outside the atmosphere, and then again it made its final entry. So ये जो coming back in the atmosphere, going away, again coming back, this is called skip entry. Now you can ask a question, why skip entry? Why NASA did that? So there are many reasons, not one but there are many reasons. By doing skip entry, first very important reason is that as you enter towards Earth you have very high velocity. With the help of skip you actually reduce your speed. Now reduced speed means that you are falling towards Earth with less speed. Less speed means that you are going to face less air drag. Less air drag means that overall the heat which is going to be generated and temperature which is going to be increased, that is not going to be as high if it had directly entered. So direct entry में जो है there is a more threat. हमेशा जो atmospheric re-entry होता है वो बहुत dangerous होता है. I hope सबको clear है ये. That whenever you are entering from space into atmosphere, suddenly you have lot of air friction. That air friction is going to generate lot of heat energy, and that heat energy actually may harm or it can cause accidents also. So skip entry का जो सबसे पहला benefit ये है that you can actually reduce your speed when you are going to re-enter, and with that you can actually reduce the atmospheric friction you are going to face. But there is another benefit, that if you time it perfectly, then you can precisely find out what is at which location you are actually going to enter into Earth without consumption of lot of fuel. That even though you entered into here, जो final आपका dropping point on Earth होगा वो thousands of kilometers होगा, and for this thousands of kilometers of travel you do not require any extra fuel, and if you time it perfectly you can exactly come to the point where you want to land. So it also gives you more precision that in which part of, let's say if you have to land into Pacific Ocean, कोई भी जो mission होता है जब वापस Earth पे आता है, it has to land into some ocean. Let's assume into a particular region of Pacific Ocean. With the help of skip entry, you can precise your landing. So Artemis mission, I think you have to know three things here for on this mission. First, it is NASA का जो पहला Apollo mission था 1969. So NASA announced one more lunar mission, but it is actually not one but three mission. First is unmanned, which has become successful. Second will be manned, but that will be not going on the surface of moon. Third is going to be a manned mission again, but will land on the surface of the moon. तो वो तो चलो, I don't think that is important. What is important here is that this mission had a spacecraft called Orion, and the goal here was to attain an orbit which is called distant retrograde orbit, which simply means that moon का जो direction है around Earth, this orbit, this Orion spacecraft has to maintain orbit opposite to that motion. That opposite motion gives it more stability. NASA wanted to check it. Theoretically they knew it, but they wanted to check it that if it is true or not, and they have become successful in doing it. And while coming back, they used a thing called skip entry, which simply means that they first enter into atmosphere, but then again went outside the atmosphere, again entered. By doing that, they were able to reduce the amount of heat energy will be generated, and they are also able to ensure that precise landing जो है वो हो सके. तो ये जो skip entry है, that is also an important keyword which I think you should remember in the context of this mission. Let's take a break here. I have been speaking for very long. On the moon surface बिल्कुल नहीं था. Artemis mission में landing on moon surface नहीं था. Just a stable orbit around moon and coming back towards Earth. ठीक है? And the name of that spacecraft was Orion. ठीक है? next topic which is given in your material is James Webb Space Telescope. There's a question that there are so many satellites revolving around Earth, space junk is also present in the orbit, how do this avoid space accidents? I will come to that part. ये discuss करना है हमको, एक space debris वाला topic दे रखा है आपके material में, so we'll have to discuss it. Webb telescope was asked by UPSC just last year in mains examination. So I consider this to be more important perhaps for next year prelims rather than this year prelims. बहुत कम होता है rarely UPSC same theme पे consecutively question पूछे. But Webb telescope, by the way, nonetheless is going to be remain important for many years because every day it is discovering something about universe which is challenging our current level of understanding. For example, last week it discovered some of the heaviest galaxies which were formed just few million, 100 million after Big Bang. And हमारा जो अभी understanding of universe है उसके हिसाब से वो possible नहीं होना चाहिए. So it is already discovering lot of things which is challenging our current level of astronomy. So it is going to be in news for many more years to come. So in any case, what exactly this Webb telescope is and why this requires a dedicated coverage here. First of all, I hope everybody is clear about telescopes' purpose to look at the distant objects in the sky. We are talking about taking pictures of stars, galaxies, etc. I will explain gravitational lensing, what is gravitational lensing, but let me briefly tell you about Webb telescope, that why this telescope is such a big deal. So it is a big deal because of mainly 4 reasons. In fact, I might have slide on it. Yeah. So this telescope is a big deal because of mainly 4 reasons. And those 4 reasons make it capable. So a 5th reason also I'm going to talk about. The very first reason why this is so significant is because of its size. Telescopes के mirrors जितने large होंगे उतना ज़्यादा data वो collect करेंगे from the distant sources in the sky. जो Webb telescope के जो primary mirrors हैं, these mirrors in terms of area they are about thrice more than Hubble telescope. And Hubble is considered of course a very powerful telescope orbiting around Earth. So that is the first reason why Webb telescope is such a big deal, that it is the largest mirror which has been launched into space as of now. The largest, not one of the largest, the largest mirror which has been launched as of now in the space. Much more area means more collection, more accumulation of light, better resolution picture. That is the first reason. So first reason is size of telescope. Second reason is it is observing universe in what we call infrared light. I can look at things into visible light, which by the way our eyes can look at things only in of course visible light. But if I have a camera which can look at things into infrared light, then that camera can actually tell you about lot compared to a visible light camera. You see, infrared light is not at all bothered by presence of dust. जैसे एक सिंपल से इमेजिन करो that बहुत सारा dust storm चल रहा है, you are driving, you cannot see anything beyond this dust. If you have however infrared camera, you can look beyond this dust is like totally not present in front of you. So infrared camera का सबसे बड़ा benefit ये है that I can, by the way, universe speaks to us in many lights, many type of frequencies. I can observe universe into X-ray, ultraviolet, visible light, infrared. Infrared light has lot of benefit, that lot of things it can filter out. It can just simply filter out as if they are not there. During night, for example, if this room suddenly becomes completely dark, we will not be able to see each other. But if I have an infrared goggle, I will be able to see all of you because all of you have a unique heat signature, and whenever our body is emitting heat, that is infrared light. So with the help of infrared light, I can see exactly where all of you are sitting here, even though this entire room becomes dark. So infrared cameras or infrared light, observing things into infrared has a lot of benefit compared to visible light. So Hubble जो है, that was observing universe into visible light and ultraviolet light. जो Webb telescope है, that is observing universe into infrared light. Because of this infrared, lot of cosmic dust, it can look beyond it. It can look at the distant stars and galaxies. So that is the second reason why this telescope is such a big deal. The third reason why it is such a big deal, that where it is. जो हबल टेलीस्कोप है, that is orbiting around Earth at the altitude of about 500 kilometer. I do not remember the exact altitude, but I am very sure it is around 500 kilometer. So it is a earth-bound orbit. जो Webb telescope है, that is in an orbit which is called halo orbit around a point which is called Lagrangian point 2, 1.5 million kilometer away from Earth. So Hubble has an orbit of 570 kilometer. Moon has an orbit of around Earth 384,000 kilometer. जो Webb telescope है, that is 1.5 million kilometer away in the same line, sun earth line को अगर हम draw करें, it is 1.5 million kilometer away from Earth in the opposite direction compared to sun at a point called L2 or Lagrange point 2, and it is orbiting around this L2 point. And because of this orbit by the way is a very complex orbit. So generally whenever we are talking about an orbit, it requires gravitational force. That goes without saying that कोई भी revolution है, किसी भी type of circular motion के लिए, you require a force which is called centripetal force, a force towards center. Any type of orbit, I require a force towards center, and that force is called centripetal force. In case of orbits of satellites or any space probe for that matter, that centripetal force occurs because of gravitational attraction. Just if there is a satellite which is revolving around Earth, then it is revolving around Earth because there is a gravitational attraction between Earth and this satellite. Does Moon have some impact on this orbit? Does Sun have some impact on this orbit? The answer is very limited. We can neglect it. They are because so closer to Earth, we can neglect the impact of Moon or other celestial objects on an orbit which is not very far away from Earth. But if I go very far away from Earth, then other objects का जो influence है, gravity के साथ क्या है? Bigger the object, more will be the gravitational force. But then more the distance, less will be the gravitational force. m1 m2 by r square. यही होता है ना gravity. Two objects separated by distance r, the gravitational force varies m1 m2 by r square rule. Larger the mass, more is the force. This is proportionality sign. More the distance, less is the force. So Lagrange was a scientist who lived few decades after Newton, who was trying to find out that can I find a stable orbit because of three objects. So I need two objects, and can I find a stable orbit for the third object. However, for this third object, the required centripetal force is not coming from one but the combined effect of two. Again, remember my problem. My problem is that I need an orbit. That orbit requires a centripetal force. Often centripetal force occurs because of gravity. For example, if there is a satellite revolving around Earth, gravity is providing the necessary centripetal force. That gravity is because of Earth only. But Lagrange was trying to find out that can I find similar orbit, but the required force जो है, जो required centripetal force है, that is not coming from one object but from two objects. So Lagrange came to a conclusion that in general stable orbits will not be found, with one exception, and that exception is that जो third object है वो बहुत small होना चाहिए compared to the two larger object. जो आपका third object है, that should be very very small, and in that case Lagrange was able to show that in such cases I can find 5 special points, and around these 5 special points the required centripetal force will come from the combined gravitational effect of two larger objects. जैसे imagine a system including sun and including earth. Now compared to sun and earth, any type of probe, उसका मास तो नेग्लिजिबल ही होगा ना. सन इज वेरी हैवी, अर्थ इज वेरी हैवी. कोई भी प्रोब हो, कोई भी सैटेलाइट हो, उसका मास तो हम नेग्लेक्ट ही कर सकते हैं. So Lagrange mathematically showed that if this is a special case, that my third object, in this case that is a probe, or in this case that is Webb telescope, if my third object is very very small, in such cases I will find 5 special points into space, and these 5 special points are named after him, which is called Lagrange point. 3 of them will be on the straight line, which will be on these 2 larger objects, meeting these 2 larger objects, and 2 points will be perpendicular to the straight line. And the required centripetal force basically will come from the combined gravitational effect of both Earth and Sun. By the way, I can find this 5 Lagrange point for any system. For example, I can find Lagrange point for Earth Moon system or for Sun Jupiter system. So I can take any 2 larger object which already are gravitationally bound to each other, and then for any 2 such larger object I can find 5 Lagrange points. Around these 5 Lagrange points, jo if I keep my probe, any type of probe or my telescope, then for this telescope to maintain a stable orbit, it actually does not require, it will not get its centripetal force from just one object, but the combined effect of both of the object. So in Earth-Sun system, for example, there is a point called L1 point. Here we are going to keep our mission called Aditya L1 mission. This is also a very important topic according to me, because this will be launched this year only. अभी जो इसरो का प्लान है, इस साल हम आदित्य मिशन लॉन्च करने का प्लान कर रहे हैं बाय द मंथ ऑफ जुलाई. तो प्रीलिम्स नहीं तो मेंस में तो इम्पोर्टेंट हो ही जाएगा अगर प्रीलिम्स में नहीं आता है. L2 मिशन, जो L2 पॉइंट है, अराउंड दिस वेब टेलीस्कोप जो है जेम्स वेब स्पेस टेलीस्कोप, इट इज केप्ट and it is 1.5 million kilometer away from Earth. Now here is the thing, if something is far away from Earth compared to Sun, then Earth is revolving around Sun in 365 days. If something is far away from Earth, compared to Sun, then it should revolve in less than 365 days. If something is closer to Sun compared to Earth, then it should revolve in, they should revolve more than 365 days. They should revolve less than 365 days. Now, why this point is so useful, L1 or L2? L1 is very useful for solar observation. कि मान लो मुझे सन को ऑब्जर्व करना है, सन के बारे में डेटा कलेक्ट करना है. Then if I am calculating this data from a earth bound orbit, if I am calculating a data from an earth bound orbit, then for half of the time it is behind Earth, Earth is blocking its point of view, like an eclipse. Because it is revolving around Earth, for half of the time it cannot actually monitor any data about Sun, because Earth is blocking its point of view. Only for half of the time it will be able to collect data from Sun. So ideally I should go to a solar orbit. Ideally I should go to a point where something is revolving around Sun away from Earth, so that Earth does not create any type of shadow, any type of eclipse on this probe. But there is a problem. If I go closer to Sun, then I am traveling much faster compared to Earth. Earth देखो यहाँ तक पहुँचा, ये point यहाँ पहुँच गया, probe मेरा यहाँ पहुँच गया. How will I receive data from here? So I also need a continuous data, that it should be able to maintain a continuous channel of communication. So that is why this L1 point, where we are going to keep Aditya mission, this L1 point, Sun is pulling in this direction, but Earth is balancing this force a little bit. Because of this, any probe around L1 will be bound into Earth-Sun system. So as Earth revolves around Sun, L1 point is also going to revolve around Sun in exactly 365 days. So the good thing is that this is one point, this point here is 1.5 million kilometer. It can continuously collect data about Sun. At the same time, it can exchange that data, it can send that data towards Earth, because Earth is revolving in 365 days, but so is a probe around L1 point. So this is where we are going to keep Aditya mission. अभी मैंने थोड़ी देर पहले भी बताया था कि जो लॉन्च व्हीकल का जो पर्पस होता है वो कुछ किलोमीटर के बाद वो चले आता है. So for example, even if I use GSLV, let's say, GSLV will return back after a few hundred kilometers. After that, all of it is orbital adjustment. From time to time, जो transfer orbit जैसे मैंने बताया, from time to time you have to keep increasing its speed, you have to keep adjusting its motion in a way that you have to find the desirable orbit. So rocket, कोई भी जो launch vehicle है, उसका purpose has to deliver into space, into an earth-bound orbit. After that, it is about orbital maneuvering. That orbital maneuvering requires some fuel which is part of the satellite system itself. वो rocket वहाँ पे role play नहीं करता. By that logic हमने PSLV मंगल मिशन के लिए यूज़ किया था. तो इसका मतलब ये नहीं है कि PSLV did carry that mission up to Mars. It only ejected Martian mission MOM into an earthbound orbit. After that it is all about maneuvering, that how you are going to change its orbit with the help of other objects, with the help of some fuel perhaps which is kept here, right? So this point can continuously monitor sun, at the same time send data towards earth. And Webb telescope के साथ भी same benefit है. जो lunar orbit है, that is about 384,000 kilometer. L2 point is far away from sun, but in this case the gravitational attraction is in the same direction. So as earth revolves around sun, L2 point is also revolving around sun. If I have a telescope around L2 point, then it can continuously look at the sky, imagine this part of the sky, without being blocked by either earth or moon. जो Hubble telescope है, if it is monitoring a, for example, imagine Hubble telescope around earth. Hubble telescope is monitoring this part of the sky, but again if it is around in this region of earth, it cannot monitor this part of the sky because earth is blocking its view. So a telescope here can continuously monitor the deep space without being blocked by either earth or moon. But the best part is that despite the fact that it is so far away, as earth revolves in 365 days, so does this point. So it can also maintain a continuous communication channel with the help of communication channel with ground stations on earth. So that is the benefit of L2 point, that it is very suitable for telescopes. L3 is not useful because it is always going to be remain behind sun. तो यहाँ पे से ऐसे कोई भी अगर हम प्रोब लॉन्च करेंगे भी, तो पहले तो लॉन्च करना ही मुश्किल है. अगर कर भी दिया तो हम कम्युनिकेट कैसे करेंगे, बिकॉज इट इज़ ऑलवेज बिहाइंड सन, नॉट यूजफुल. L4, L5 as of now are not being used. Maybe in future they will be. But L1 very useful for solar observation. L2 very useful for telescopes. L1 पे already कुछ missions है. There are few missions. There is a very famous mission of NASA called SOHO mission. तो आदित्य ऐसा नहीं है कि कुछ यूनिक होगा अराउंड L1 point. This is called Solar and Heliospheric Observatory. This is a mission of NASA. And even around L2 there is another telescope of European Space Agency. But nonetheless, जो Webb telescope है, that is of course very powerful, and it is able to collect lot of data. So that was the third thing, that why Webb telescope is such a big deal. So I told you 4 things. First was that its size is much bigger. Second is infrared. It is observing universe into infrared. Compared to that, Hubble is observing into visible or ultraviolet. Third, its location at L2 point, 1.5 million kilometer away from Earth. And fourth is, by the way, this part. ये जो आपको दिख रहा है, ये तो टेलीस्कोप का मिरर है, but this part, तो telescope is here, but there is a infrastructure here. That infrastructure is actually a sunshade. It is as large as perhaps a tennis field. Lawn tennis जितने बड़े एरिया में होता है, इतना बड़ा है. This is going to block any type of sunlight. It has solar panels. First of all, solar panel इसको चाहिए, power तो चाहिए ही, because it is collecting data. It has to send data also to ground station. So it has solar panels so that it can continuously collect data. But that is not its job. ये जो infrastructure है, there are 5 layers here. And those 5 layers are going to block any type of sunlight. Now why this blocking of sunlight is important? Because in this telescope, whatever light is being collected, we do not want this light to be disturbed by presence of sunlight. In fact, there is also a chance that if it receives lot of sunlight, if it becomes heat up enough, then it will start emitting its own radiation. All objects, if they have lot of heat energy, what they will do? They will radiate that energy. Even Webb's own radiation can affect astronomical observation. So we want to ensure that ये जो side है, that remains at very low temperature. So that is why, for example, while this side temperature can be about 85 degrees Celsius, after a few degrees Celsius the water will start boiling. But ये जो layers हैं 5 layers, ये completely sunlight को block कर देंगे, so that this side is going to remain perhaps at the temperature of minus 230 degrees Celsius, where I can have nitrogen into liquid stage. So that is the fourth unique thing about Webb telescope, that it has a very powerful sunshade, and this sunshade will shield it from the sunlight. And why this is important? Because we do not want any type of disturbance from sunlight or Webb's own radiation in its astronomical observation capability. And because of all of that arrangement, Webb can actually look back into the universe when universe was very young. Universe hardly was formed. Big Bang happened about 13.7 billion years ago. The objective of Webb telescope is that it can look back into the universe when it was hardly 400-500 million years old. Compared to 13.7, 400-500 million year old young universe is a very young universe. So the early stars formation or the early galaxies formation, Webb can look in. By the way, it is precisely doing this. तो अभी जो मैंने थोड़ी देर पहले आपको बताया था कि last week, not even a very old news, last week, as of now, Webb has collected data, and that data has frankly broken all astronomical models. That जो भी हमारा based on whatever our idea of gravity, we had developed that how universe came into existence. As per this model, the first galaxies would have started perhaps after 600-700 million years after the formation of universe. But Webb has shown that there were very massive galaxies as young as 400 million year old universe, and that does not fit into our current understanding of universe. Now here is the thing, science is all about collecting data, is about experiment. So based on that data, now we have to revisit our understanding of universe. So lot of things, other things are also given in your material. So, sorry? Oldest stars and galaxies, yes. Lot of things are given here. So Lagrange points का जैसे एक definition दे रखा है. At Lagrange points, the gravitational pull of two large masses precisely equal the centripetal force required for a small object to move with them. So Aditya mission जो है, that will be, by the way, placed at L1 point. In space, it is the largest telescope. NASA, not NASA, this is a combined effort of NASA, Europe and Canadian Space Agency, but NASA of course has the maximum contribution here. तो जो Webb telescope जो contribution है, that is of 3 agencies, NASA, Canadian Space Agency and European Space Agency. Lot of things are given here. For example, it captured beautiful images of Jupiter, its moon, it found aurora. जैसे अर्थ पे aurora बनता है, वैसे जुपिटर पे aurora बनता है. अच्छा, it has found some of the nebulas which by the way were captured by Hubble telescope itself. Nebula वो regions होते हैं जहाँ पे raw material है stars formation के लिए. That regions which spans thousands of light years, they have cosmic dust traveling with very high energy, and that cosmic dust is like raw material for formation of a new star. So these regions where you have this raw material, these regions are called nebular regions or simply nebula. So some of the nebulas which are very popular, part of Milky Way itself, just there is a very famous nebula called Pillar of Creation. The first image was taken by Hubble telescope. This nebula basically. That this region which spans thousands of light years in the universe, it has all the raw material required for formation of new stars. So there are many such nebulas. The part of Milky Way itself, also we know of distant nebulas. So Webb has actually captured images of these nebulas, much better nebulas, much better resolution compared to what Hubble had captured. Not only this, its resolution is so good that एक तो concept होता है exoplanet का. Exoplanet, any planet which is not part of solar system is called exoplanet. But then you also have something called exomoons, that जिस तरीके से very similar to how Earth has a moon. Even exoplanets can have their own moon. But exomoons को detect करना, how challenging that will be into a distant star system, thousands of light years away. Clearly, it is going to be very challenging. But Webb is so perfect, it has such high resolution power that it has actually captured images of exomoons. Many other things are given, nebula, different type of nebulas, a deep field view, basically just part of universe where many galaxies and stars are kept together. Nebula, Carina Nebula, Einstein ring. All of these definitions are given. I think it should be very clear. Kuiper belt is basically region of solar system which is beyond Neptune. जो पूरा Neptune, Pluto और उसके beyond जो region है, there are very smaller particles there, icy particles which are revolving around sun. So that region of the solar system is called Kuiper belt. Asteroid belt is lot of asteroids revolving around sun which lie between Mars and Jupiter. Exoplanet, any other planet outside solar system. Nebula is basically cloud of dust, cosmic dust, which is like raw material for formation of new stars. Now there is another term which is given here, gravitational lensing. That what do I mean by gravitation? What do you mean by gravitational lensing? सबसे पहले तो if you recollect your class 9th or class 10th science classes, that one of the things lenses do is that they can converge light. They can converge parallel light at a particular point. If it is parallel to their axis, then at focus. If it is not parallel, but even then that can be converged in the focal plane. So parallel lights can be converged by a convex lens, for example, at a point. So convergence of light, that is done by lenses. Now imagine a situation that there are distant galaxies very far away from Earth. Earth is here somewhere. You do not have, जो भी telescopes यहाँ पे होंगे, चाहे Hubble हो, Webb telescope हो, whatever light which is coming from these distant galaxies, it is so faint that you will not be able to find basically any good image here. It depends upon how much light you are able to actually collect. They are so far away, so distant that you will not be able to collect good amount of light. You will not be able to have any type of picture as such. But if by chance in the region you have cluster of galaxies or galaxy in general, so galaxies are very heavy. I am talking about many galaxies moving around together in a region. Light coming from this galaxy. Now here is the thing, even light is affected by gravity. We do not see that in our day-to-day life because Earth is frankly not that heavy. Earth के respect में light जो है straight line में चलेगा. Earth is not that heavy. But if you are, let's say for example, near a neutron star or near a galaxy cluster of galaxies or near a black hole, then even light will bend. Light will not seem to be going into straight line. So because of this heavy cluster of galaxies, light which was very dim going into other region, but it can bend and it can converge. Now converged light का जो intensity है, that is going to increase. So the light which was very dim would not have given you good picture, but that light now bend towards very similar to how a lens converges light. So this effect, by the way, this is happening because of gravitational effect of this cluster of galaxies. Hence the word we use is gravitational lensing. So gravitational lensing हमेशा होता है. In astronomy, what we use it for? We use it to take good pictures of very distant galaxies, very distant stars. So it's a very powerful tool in astronomical observation to take picture of distant stars and galaxies, that even though the light coming from them is so faint that it will not give you good pictures, but with the help of another cluster of galaxies, that light can be converged and that converged light can actually give you picture of distant stars and distant galaxies. So this is called gravitational lensing, and we simply call it gravitational lensing because it has a very similar effect of lens, how lens converges light. But in this case, this convergence of light is happening because of cluster of galaxies, gravity basically, gravitational effect जो है, that is leading to this convergence, hence the name gravitational lensing. Now here is the thing, because of this convergence can occur in some times, in some ways, that light from one source, but because of this convergence it may seem like that it is coming from many sources, and because of that the image you are going to get, that image will be like a ring. There is one galaxy, but this convergence light, it is converging at different point, and it can make a ring like structure. If you look at the image, you will find a ring, you will find many images of the same galaxy into a ring formation. This was first hypothesized by Einstein, and because of that it is called Einstein ring. तो ये भी आपके मटेरियल में दे रखा है. Although I do not expect Einstein ring पे UPSC का क्वेश्चन कि what exactly is Einstein ring, but ये भी दे रखा है, it is visible when light from a star or galaxy passes another galaxy or massive object on its way towards Earth. So what happens is that because of gravitational lensing, same object, same source of light, but this convergence happens in a way that the final image you are going to find, rather than looking at one galaxy, you will find many galaxies into a ring formation, into a circular shape, and all of those galaxies are actually one galaxy only, and such formation is called Einstein ring, and sometimes that is also witnessed, but that also happens because of gravitational lensing. So any question in this topic? I do not expect questions to be frankly very complicated. Very simple question. Lagrange points क्या है, halo orbits क्या है, आदित्य L1 mission, where exactly. So simple definitions, आदित्य mission के objective, something like that. So I do not frankly expect very technical or very difficult question to be asked by UPSC in prelims examination. So if you have any question, please go ahead and ask. वो भी दे रखा है आपके मटेरियल में, वो भी हम डिस्कस करेंगे. नहीं है ना, बहुत दूर दूर तक कोई ऑब्जेक्ट ही नहीं है. The question is that can other objects have impact at L2 if it is 1.5 million kilometer. Now 1.5 million kilometer in our frame of reference is a very large distance, but into astronomy 1.5 million kilometer is nothing. जो nearest, जो next planet होगा, Mars or Jupiter which can have some impact, it's so far away, it will have negligible impact. So we can easily neglect the impact of other objects in the sky. Any other question? The next topic, I consider this topic to be more important for mains examination, but nonetheless for prelims there are few things which should be very clear. First, government in 2020 announced that अभी तक जो space as a domain था, वहाँ पे ISRO का monopoly था. ISRO was doing everything. ISRO was making rockets, launching satellites, collecting data from those satellites, using that data for remote sensing, for geospatial data, etc. So ISRO had monopoly in lot of things. From time to time, ISRO used to launch smaller satellite from private companies, but even ISRO used to launch. But government in 2020 announced that we are going to allow private sector participation, that even private companies can make rocket, can launch their satellites. And for that, government also announced that we are going to facilitate their entry. What this facilitation means, that space requires lot of initial investment. So that initial investment बहुत startups के पास होगा नहीं. तो we do not want a situation जहाँ पे एक मोनोपोली हो जाए कि सिर्फ रिलायंस है या कोई बड़ी कंपनीज है, ओनली दे आर, और डुओपोली हो जाए. सो वी वांट प्राइवेट सेक्टर पार्टिसिपेशन बिकॉज वी वांट मोर कंपटीशन. मोर कंपटीशन विल मीन मोर इनोवेशन, more research and development, more employment generation, right? Doing things at lower cost, all of those things will be consequence of more private sector participation. But monopolies or duopolies, that cannot be very good. So we have to ensure that जो भी private sector participation है, that remains predictive. जो भी हमारा policy है वो predictive हो, किसी भी type का preferential treatment ना हो, that some companies are being preferred over another. In India that is very difficult thing. हमारा पूरा record बड़ा खराब रहे इस चीज़ को लेके. In other sectors, private में space में तो हमने allow भी नहीं करा था अभी तक. But this is what we are trying to do. So to ensure that, the first thing from prelims perspective which you have to remember is this body called InSpace. So InSpace is frankly a regulatory body. It works under Department of Space, not under ISRO. पहली चीज, ये ISRO के अंडर नहीं है बॉडी. ISRO डिपार्टमेंट ऑफ स्पेस के अंडर काम करते हैं. डिपार्टमेंट ऑफ स्पेस कौन से मिनिस्ट्री के अंडर काम करते हैं? प्राइम मिनिस्टर. डज नॉट वर्क अंडर एनी मिनिस्ट्री. सो जो इन स्पेस है दैट विल वर्क अंडर डिपार्टमेंट ऑफ स्पेस, बट इट विल नॉट बी अंडर ISRO. In space in itself is a independent autonomous organization. The objective of InSpace is that we have to ensure predictive policy. We have to ensure that any type of private player, if they want to, let's say, use ISRO facilities, ISRO has dedicated facilities, private companies, we can facilitate ISRO facilities for such private companies without any type of preferential treatment. We do not want regulatory requirements which keep on changing. We want predictive regulation. कि जो भी regulation है, private companies अपना एक mindset बना के आए हैं कि these are things we are going to expect. But कल को कोई government आए या कल को government को कल लगा कि नहीं let's change this regulation. That should not happen. By the way, India इसके लिए भी बहुत बदनाम है that we keep changing our policy. So that should not happen. So for all of that, we have created this body called InSpace, which will work under Department of Space. Mandate is sharing of space infra, establishment of temporary facilities under ISRO, establishment of new space infra and facilities, with this goal of facilitating private sector participation into space activities. There will be a chairperson. For example, chairperson will not be some minister, does not have to be some minister or perhaps ISRO's chairman. That was the initial plan. ISRO का जो chairman होगा, that will also be chairman of InSpace. But as of now, that is not the case. But some person with some technical expertise and other members, which will basically ensure that this body works independently. तो एक तो ये चीज़ पता होना चाहिए prelims exam के लिए. Now compared to that, जो New Space India Limited है, that is a commercial wing. That as of now it has a legal mandate to manufacture both PSLV and SSLV. जो PSLV और SSLV launches हैं, they are happening with the help of New Space India Limited. Another mandate of New Space India Limited is that it will also enter into collaborate with private companies to perhaps for future launches. But New Space India Limited is a commercial wing. जो InSpace है, that is a regulatory body. Which one? So New Space India Limited, because it works under ISRO and ISRO is under Department of Space, so in a way yes. But जो New Space India Limited है, now that is under ISRO. InSpace is not, right? तो ये difference जो है वो clear होना चाहिए. तो एक ये चीज़ prelims examination के लिए, that as of now private sector participation is allowed and there is a regulatory body called InSpace. Now second thing which according to me is important, that for the first time a private company launched a rocket. So private companies have launched satellites into past. They have made satellites and with the help of ISRO's rocket they have launched their satellite. That is not new. But what is new is that there is a company called Skyroot Aerospace, and that Skyroot Aerospace launched a single stage rocket called Vikram, named after Vikram Sarabhai. So they call this rocket Vikram S. The goal here was that let's achieve an altitude of about 100 kilometers. It did not make one complete orbit around Earth, but nonetheless it did enter into what we call suborbital flight. That not one complete orbit, so but some time into space and again returning back towards Earth. So it was able to do that. So that is the second thing I will remember, that a private company called Skyroot Aerospace launched first private rocket which was named after Vikram Sarabhai. इसके अलावा इसके डिटेल्स, कितना हाइट था, क्या था, इतना डिटेल नहीं जानना है. तो ये बाय द वे व्हाई दिस वाज हिस्टोरिक, बिकॉज इट वाज द फर्स्ट प्राइवेट रॉकेट लॉन्च. प्राइवेट सैटेलाइट्स बहुत सारे पास्ट में लॉन्च हुए हैं. Such type of bullet points are more useful for mains examination. What are the steps taken by Government of India to promote private sector participation? So NSIL, which is a PSU basically, collaborates with private companies. Private companies themselves have formed an association called ISPA, Indian Space Association. Antrix, which is a commercial wing of ISRO, And ISRO has also a dedicated fund as of now called Seed, Space Entrepreneurship and Enterprise Development, कि जो भी young startups होंगे जिनको capital requirement है, if their idea is really good, then it can be helped with the help of, it can be supported with the help of ISRO. एक क्वेश्चन ये हो सकता है कि जब एंट्रिक्स था तो गवर्नमेंट ने बनाई ही क्यों NSIL? तो एंट्रिक्स जो है अभी एज ऑफ नाउ एंट्रिक्स इज इन लॉट ऑफ लीगल बैटल. एंट्रिक्स इज सफरिंग फ्रॉम सम लीगल बैटल एट द ग्लोबल स्टेज. As I told you, government of India is not very famous for fulfilling its contractual obligation. So one of the contractual obligation on the case of corruption was revoked few years ago, and the company did not like it, and they have actually went to international tribunals and they have won some cases. So as of now, government of India is not happy with the working of Antrix. Maybe that was a reason why they created a new commercial body. हमारा रिकॉर्ड हमेशा रहता है कि हम अपने स्ट्रक्चरल प्रॉब्लम्स ठीक नहीं करते, हम एक नया बॉडी बनाते हैं. तो वी क्रिएटेड अ न्यू बॉडी, न्यू स्पेस इंडिया लिमिटेड, बट द ऑब्जेक्टिव इज वेरी डिफरेंट. जैसे जो न्यू स्पेस इंडिया लिमिटेड है, जो डेडिकेटेड फोकस ऑफ PSLV एंड SSLV, उसका जो प्रोडक्शन लॉन्च ऑल ऑफ दैट विल बी मेंटेन्ड बाय न्यू स्पेस इंडिया लिमिटेड. जो एंट्रिक्स है, दैट इज टू कोलैबोरेट विथ अदर प्राइवेट कंपनीज, सैटेलाइट्स, लॉन्चिंग ऑफ देयर सैटेलाइट्स, ऑल ऑफ दैट. सो पहले बाय द वे ये सेम ऑब्जेक्टिव जो है एंट्रिक्स के पास था, बट ग्रेजुअली गवर्नमेंट इज गिविंग दैट रिस्पॉन्सिबिलिटी फ्रॉम एंट्रिक्स टू NSIL. Not necessarily, but one of the mandate is that it can collaborate with private companies. The question is that, is there a legal or is there some sort of mandate that it has to collaborate with private company? It's not a mandatory, obligatory thing, but yes, it can definitely collaborate with a private company. Not for production, for specially production of SSLV and PSLV, that is dedicated focus of NSIL, right? But for example, once satellite has been launched, then collecting data, maintaining that data, all of that NSIL can be useful. Achha, that is interesting. I did not know that. So thanks for. Antrix was also PSU. So that is a wrong statement. If that is written for first public undertaking in space sector, no, that is a wrong statement. Antrix can be considered the first PSU in the space sector. So again, if NSIL is, if this statement is taken from NSIL website, then I think that is how NSIL is projecting itself. And then your point actually has it makes a lot of sense. That जो Antrix है, that was not involved into production. It was involved into commercial dealing, while NSIL is actually involved into production. I do not know, I haven't actually read about the details of it, but if that is correct, then if that is correct, then this statement makes sense, that it is a first public undertaking in the space sector. However, at the same time, I will tell you that I will consider only this statement to be accurate if it has been picked up from NSIL website itself. If it has been picked from any other source, then I will not consider that statement to be correct. So I will confirm it in the next class, that what is mentioned on the NSIL website. It is under Department of Space, yes. No, not under the control of ISRO. It helps. So for example, एक जो statement जो दे रखा है, वो यहाँ पे ये भी है, decisions of in space in the context of this mandate shall be final and binding on all stakeholders including ISRO. Forget it, mandate ISRO के साथ collaborate करना ये है, but if there is a conflict where ISRO and some stakeholder are into some sort of conflict, then the decision will be binding on both of them. So in that sense, it is autonomous. So if there is a statement that in space is an autonomous body, especially autonomous, different from ISRO, then that statement will not be a wrong statement. But if the statement is that it has nothing to do with ISRO, then clearly it is a wrong statement, because still one of the most important mandate in space has is that it is going to facilitate private sector participation with the help of ISRO facilities, right? With in space. In space is also under Department of Space. New Space India Limited is a commercial wing of ISRO. So not so overall in organizational structural point of view, Department of Space, ISRO, Antrix and NSIL, right? So in that sense, all of these bodies are under Department of Space. There is a topic called space sustainability. Now that is a more important topic for मेंस एग्जामिनेशन, बट इसके जो बुलेट पॉइंट्स हैं कि स्पेस सस्टेनेबिलिटी का सबसे पहले तो मीनिंग क्या है वो क्लियर होना चाहिए. वी आर टॉकिंग अबाउट यूज ऑफ स्पेस not for today but also for future. That is after all the meaning of sustainability is. So when we are talking about space sustainability, then it means that there are certain issues which we are facing right now that may be our space missions into future, or maybe even today there is some problem or there are some problems associated with them. So in this topic those are more important. यहाँ पे जो ये context है that there was a forum, that context is also not important according to me. But what is important is these threats, all of these threats which are mentioned. So let's discuss all of them one by one. The first and the most important topic which you should know is this issue of space debris. So debris is any unwanted object into space which may be detrimental to our space mission. Any type of orbital junk traveling around Earth with very high speed can be called space debris. Because they travel with very high speed, even a small piece of debris can actually collide and cause a lot of damage to our space assets, perhaps a satellite, perhaps another space probe, a telescope, etc. So there are millions of pieces of debris which are very small. Imagine them like dust particle. That number is into millions. What we need to do is that they will cause some sort of corrosion. जैसे जो international space station है, it is always corroded because of such type of very smaller debris. Because of that, from time to time they have to keep changing their window. That does not cause as such permanent damage or a dangerous accident. But जो larger debris हैं, debris with size more than 10 centimeter, 20 centimeter, perhaps like a tennis ball. Imagine them like a tennis ball or larger pieces than that. They often travel with very high speed. Many of them are traveling with speed perhaps 5 times, 6 times, even 7 times than speed of a bullet coming out of the gun. Now imagine an object with size of tennis ball traveling 5 times speed of a bullet, and if that goes and collide with space station or any satellite, there is just no chance that satellite is going to survive. So space debris is a serious issue as of now. So the first question you can ask is that how are they created? What are the sources of space debris? So sources can be both natural and man-made. Natural sources क्या होंगे? बहुत सारे meteorites, micrometeorites, their part got separated, is orbiting around Earth. उनका आप कुछ कर नहीं सकते. जो भी natural creation है, उसका तो आप कुछ कर नहीं सकते. वो आप irrespective of what you do, from time to time there will be natural sources. But what you can do is about man-made sources. Now what are man-made sources? So man-made sources can be of many types. One of the things can be जो upper stages of rockets हैं, जैसे PSLV, I talked about that it has 4 stages. जो 4th stage separation होगा, in that separation some components will also be separated. If they have enough speed that rather than falling towards Earth, if they complete one stable orbit, then they will just keep orbiting around Earth. So जो rocket के upper stages हैं, they are often one of the biggest source of space debris. First. Second, some accidents have occurred in the past. Rocket upper stages have exploded, satellites have collided, very rare, but they have happened. And those rare events also have produced thousands of pieces of debris. That is also a very important source. Third very important source is what we call, by the way it is also given here, anti-satellite weapons. That some countries, including by the way Government of India, what we have done here is that we have destroyed a satellite into lower Earth orbit by a ground-based weapon. So few countries have achieved this capability, US, China, Russia, India. All of them have successfully destroyed their own satellite with the help of a ground-based weapon. That is often to demonstrate to your enemy nations that in the time of warfare we are actually capable of destroying your satellite also. But such type of destruction, just when India also did this, India did 17 under a mission called Mission Shakti. So when India also did it, there was a lot of furor, and recently again there was a lot of furor when Russia did it. So Russia has done this in past also, again did the same thing where it destroyed its own satellite with a ground-based weapon. That can also be a very important source of space debris. That also poses a challenge to the space sustainability, because this has this possibility of increasing the conflict among nations, and that conflict cannot be very good for humanity in general and space exploration in particular. Other things can be that if two objects are into very close proximity with each other, then there is chance of accident. And I will give you a very good example. Last year, in the month of January, Chinese space agency, Chinese government, it was furious at SpaceX, Elon Musk की जो company है, because China as of now is making a space station called Tiangong. It is under construction, complete नहीं हुआ है, कुछ साल चलेगा अभी. तो जो Tiangong construction है, that Tiangong space station was almost on a course collision with some of the Starlink satellites of SpaceX, and China was furious at it. It had to do some emergency maneuver to avoid this. So that is also a threat to space sustainability. And another threat can be that presence of lot of charged magnetized particles, especially magnetized particles coming from sun. They can also destroy your space assets. So when we talk about space sustainability, we are talking about that in general we have to be aware about what is into the space, and we especially have to mitigate those phenomena which can damage our space assets, such as satellites, stations, or telescopes, etc. So what, by the way, a very important term which you should know, a scientist named Donald Kessler, he basically imagined a situation that in future, especially the lower Earth orbit hai, that is going to become so dense that maybe one accident will produce some dense debris, and those dense debris will go and collide with other satellites. They will produce more debris, they will collide and go with more satellites. So a chain reaction, a cascade of event which will occur. It will start from one accident, but that chain reaction will lead to many more accidents, and that will further increase the chance of more accident. So as of now it has not happened, but this phenomena, so this syndrome is called, this phenomena is called Kessler syndrome, but the probability of Kessler syndrome happening in future is only increasing day by day, because space is becoming so dense. So that is also something which you should know from the prelims perspective. Now what about steps? What we can do here is mainly do three things. First thing which you can do is that you have to be aware about them, that actually larger pieces of debris है, बारे में आपको पता होना चाहिए कि उनका they can collide with your space asset in future, and if it is required you have to maneuver your satellite or space asset to avoid any type of collision. So all major space agencies track larger pieces of debris, including ISRO. So ISRO, for the first time last year, announced a project called Project Netra. You should know about this also, very important topic for prelims examination, that there is a proper facility situated in Bengaluru that involves a lot of telescopes, lot of powerful computers. With the help of these telescopes and with the type of data we are going to collect from space, we will try to simulate motion of our own satellites, we will try to simulate motion of debris, and we will try to ensure that accidents in future do not happen. But that is only one thing you can do. What more things you can do? So for example, जो creation of debris है उसके आप कुछ steps ले सकते हो. जैसे as of now there is a global demand by many countries that जो भी anti satellite demonstration को आप legally ban करो. ये अभी पिछला ये जो था यूनाइटेड, वहाँ पे एक वोटिंग भी हुआ था. US, Russia didn't support it, India abstained it. So something like this can happen, that जो भी anti satellite demonstration है that should be banned. Another step which can be taken, that जो rockets के upper stages हैं, separate them at lower altitude, so that rather than entering into a stable orbit around Earth, these smaller pieces can enter into atmosphere and burn down in the atmosphere. So something like this can happen. But one more thing which can happen is that you have to launch dedicated missions into space, so that they can trap these debris and throw them towards atmosphere or come towards the atmosphere, so that they can burn, and gradually we have to remove debris from the space. Many technologies are being explored, something like net, जिस तरीके से हम पॉन्ड में कैसे जाल बिछा के फिश पकड़ते हैं, something like a space net that launch a dedicated mission which will deploy a space net and it can capture maybe with the help of some sort of beam or electromagnetic radiation we will, or maybe we will give them enough speed so that they can enter towards space and they can burn in the atmosphere. So many technologies are being explored. Only thing is that all of these technologies are very, very expensive. So as of now, some startups have emerged that with the help of many space agencies trying to ensure that rather than all agencies doing things separately, let's fund one company, for example, or few companies. If their idea is very suitable, then fund them and they will destroy debris on your behalf. So something like this is happening as of now as we speak. There is a global body called IADC, International Agency for International Agency Debris Coordination Committee. So that agency basically is involvement of many space agencies of the world, including ISRO. ISRO is a member, and whatever data they are collecting about space debris, they share that data with each other, so that all space agencies can also be aware about presence of dangerous pieces of debris. Last topic of today's class. Only two things which you have to know here is a very famous agreement which was in news. So by the way, first there is a very famous treaty called Outer Space Treaty. Under an organization of United Nations, there is a very famous treaty. It was signed in 1968 or perhaps 67, that it is a basic framework to ensure that how space can be used as a global common. There are a lot of resources which can be called global common. Rather than belonging to one country, it is part of the entire humanity. So the Outer Space Treaty, it has a lot of features. For example, it has one feature that you cannot put weapons of mass destruction such as nuclear weapon into space. But here is the thing, it does not talk about other type of weapons. So as of now, many countries are trying to weaponize space. That is also a threat. That countries, rather than launching satellites, they are actually using space platform to place a weapon system. And maybe with the help of those weapon systems, they can target another satellite into the space, or they can target something on the earth. And that is a threat to global peace. That is also, of course, a challenge to space sustainability. So Outer Space Treaty, as of now, it is considered outdated. It needs some sort of modification. And then same organization, जो COPUS है, there is a very famous agreement called Moon Agreement. Now Moon Agreement simply signifies that moon does not belong to one nation, and कोई भी जो resources on moon होगा वो किसी एक country को belong नहीं करेगा. Simple. Now here is the thing, India is a signatory of this agreement, but जितने जो तीन बड़े agencies हैं और जो तीन बड़े countries हैं, US, China, Russia, all three of them have not signed this agreement. So as of now, they are not bound by this Moon Agreement. In fact, the very first topic I told you, or perhaps second, third topic I was discussing was Artemis mission. So as part of Artemis mission, as of now, NASA has come something called Artemis Accords. Artemis Accord is basically a set of principles that any type of outer space exploration, including lunar exploration, should follow certain set of principles. It is asking all countries to sign it. Many countries have signed it, but India has not. So India का demand है बहुत simple है, that even though by the way अगर आप principle देखोगे, पहले तो ये principle जानने की ज़रूरत नहीं है कि कौन से principles हैं, but अगर आप principles देखोगे, it is based on 7 principles. All of those 7 principles are frankly very logical. There is nothing wrong with these principles. The only problem is that it is led by US government. It is not led by United Nations. So rather than a US government led initiative, which can have its own sort of diplomatic challenges, India Russia के खुद के relation है, rather than that, there should be a UN led initiative, a UN led accord. So why India has not signed Artemis Accord as of now? Because India का demand बहुत simple है, that it should be from some global body rather than by some national space agency. But nonetheless, Artemis Accord भी news में था, simply a set of accord that aims to that future space exploration, including lunar exploration, how should it occur involving all of the countries. So it is based on certain principles, and जो भी exploration होगा, it has to follow those certain principles. बट अगेन आई विल रिपीट, एज ऑफ नाउ इंडिया इज नॉट अ सिग्नेटरी. बाकी जो है आप स्किप कर सकते हो, रेस्क्यू एग्रीमेंट, लाइबिलिटी कन्वेंशन, एक एक लाइन में बस देख लो क्या सिग्निफिकेंस है, registration convention, but these two are in news along with Artemis Accord, which you should know. Any question till now? Any question till now? So let's continue this discussion in the next class. We'll finish it, of course, space technology, and we will start our next topic, which is information and communication technology.